Hello there, everybody, and a fine and dandy good Wednesday evening to you all. Welcome back to another episode of Takeo After Dark. Are you guys ready? I've been looking forward to this all day. We've had meeting after meeting after meeting today, and it's like, I'm online having meetings like this, and I said, come on, let's go, let's go, let's go, let's go. We got things to do tonight. We got people to see tonight, and now it is time for Takeo After Dark. I'm John Barker, joined by Dave Holdorf and Rick Mayo. Say how you doing there, boys?
Hello, everyone.
How you doing there, boys?
Rick's going to be the host this evening, going over ECM Essentials. Everything you ever wanted to know about ECM circulators, but we're afraid to ask. Wait, there was another book by similar title, but we don't need to go down that road.
No.
Also joining us, the two men are feeling bashful today from Mechanical.
What's up with
Tim
that?
Ward, John Messenbrink, who don't want their faces shown tonight for whatever reason. I don't know. Maybe because they don't have Takeo After Dark T-shirts. We're gonna have
That's
to.
right.
We're gonna have to fix
Dave,
that.
you have to take care of them.
There you go.
Yeah. All right. I mean, yes, they participate, but they haven't participated, so that's why I didn't do them. So, all right.
So guys, what's going on with Mechanical Hub? Just let anybody in our audience who doesn't know, what is Mechanical Hub and what do you guys got going on this week?
Thanks, John. This is Tim. We've got our newsletter going out tomorrow that's packed full of information. We've got a feature story on an injured female veteran that was gifted a HVAC system. We've got a piece that John wrote in, Bob Mader, who was a colleague and friend of most of ours, passed away a couple weeks ago, and John wrote a piece last week that was really poignant and showed why a lot of people like Bob, and in fact, why a lot of people like John. A lot of good information. We've got obviously our podcast. We ask people if they've not listened to our podcast, go check out the two podcasts, Make Trades Great Again and Not Dead Yet, as well as we always keep the archived version of the Takeo After Dark on our newsletter. So go check out our newsletter, read the websites, and like I said, the two big features this week are on an injured female veteran with cancer and John Messenbrink's piece on Bob Mader.
I read the piece that you wrote, John, on Bob, and it was really touching. Beautiful tribute to a pretty special guy. So I highly recommend that, folks, if you get the chance to go out and give that a look-see. And tonight, of course, Takeo After Dark. As we said, this is episode 4, A New Hope. No, it's not Star Wars. It's actually ECM Essentials. And Rick Mayo is going to walk you through all the important stuff about ECM Essentials. How do you know which one of these things to use? How do you know which way to set it up? There's so many different operating modes. Rick's going to take a lot of the mystery out of that for you and make it really easy to use the right pump for the right job and for the right application. Just so we're all on the same page, if there are any first timers out there, the expanded control panel is on your screen. Look for that little orange arrow. If it's pointing to the left, click on it. That'll expand the control panel. You have your audio controls way up high. You have handouts. We got a couple of handouts for you that you can download tonight. And then the question and chat section. And I just want to make sure everybody knows how to use that. If you could just type in a hi, hello, how are you? That would be terrific. That way we know that you know how to talk to us and communicate with us. Well, that you can hear us, number one, is really important. And that's a good thing. So everybody can hear us. Good. That's you guys are populating that really nicely. And this is where you're going to ask your questions. So ask the questions as they come up, and we'll answer them as they come up as well. We'll take a break every couple of slides and talk with you and try and address your questions. And as always, we'll stay on as long as you guys have questions. Open it up about ECM circulators or anything related. And no, I did not get the blue cheese today. Darn it, I was going to go out and get some blue cheese and peanut butter and try that tonight. I'm going to have to do it next week. Rats, I forgot. Anyway, so that's that. So you know how to use all that fun stuff. If you're on a phone or tablet, here are your settings there. You can toggle using that little screen icon in the lower left. You can go between the webcams and the presentation. You have your audio settings as well. And then if you want to ask a question, obviously hit the question mark, and then you'll be able to type in a question. So that's kind of where we're at control wise. Want to make sure everybody's hunky dory with that. And
Okay.
let's get after it, man. Takeo After Dark, the winter essentials. And Mr. Mayo, you have the
Yeah,
con. Take
I
it away.
do. Okay, show my screen and hide that thing away. Bring this on and open that up. So, tell me, can you see the goals for this session? Let's make sure that's working. I'll assume we can, right?
Yes,
We
sir.
can.
Yes. Oh, you didn't.
Okay,
We can't see it.
very good. Thank
Can't see
you.
it.
Thanks
yes.
for that feedback. All right, so what we're going to try to do, John mentioned this a little bit. You know, you pull these ECMs out of the box and they do lots of things. There's lots of, 3 to 5 different modes depending on what model you have. And within each of those modes, you got a lot of settings. And wouldn't it be nice to have some general rules and some, underlying understanding of knowing what to do with those modes? And that's really what this little course is about. There's a whole lot to do with the way the system is piped. So that's why we're going to spend a lot of time just looking at sketches, near boiler piping drawings that kind of say, hey, if it's piped like this, I probably should use this setting. And realistically, that's what I want to try to get across in this session. And again, this session is somewhere around an hour. But what we know about Takeo After Dark is we'll have lots of time to expound on things. So please ask the question. And I can hear somebody typing in the background, whoever that might be, and I'm not sure who it is.
That
Hey,
would be me.
proportional pressure is it needs a little bit more understanding, right? It actually comes to us from across the pond, and we're going to kind of demystify that. We're going to make sure you understand when to use proportional pressure, and you'll understand that a lot of these adaptable auto modes are right out of the box are proportional pressure. So you'll have a good idea and a better understanding when and when not to use those. We'll actually do a little sizing example to make sure you feel comfortable with understanding a proportional pressure design. Again, in North America, not so often do we see this as a necessity, but there are some designs out there where it makes sense. So we want to give you a little bit of background on that so you'll feel comfortable when choosing that, okay? Again, adaptable auto modes, we'll kind of talk about the magic button, and that's a topic that's near and dear to John Barba, because I've heard him talk about it quite a bit. And then we'll get into an introduction of a new circulator, but Dave's going to kind of wrap things up with showing you some Bluetooth technology that you're going to see more and more of as Takeo, kind of shows off their additional product line as time goes by. So first thing to understand with ECMs is that they have an input, right? There's a couple options out there as this slide shows you, but understand these circulators don't do anything on their own, right? They just, they're going to do something based on what they either feel or they read within the system, okay? First off, we've got temperature differential. You've heard us talk about what that does for us. It's a real good way of understanding what the particular system is doing. And it doesn't really matter what the outdoor temperature is. We know it based on a load increase or a load decrease. So that is the input to a delta T, or T as in temperature circulator. That input is a couple of thermistors that are reading supply and return. Or we can actually use those circulators as set point control for variable speed injection mixing and some cool things like that as well. So again, understanding that that circulator needs an input, okay? On the other side of the coin, we got pressure differential or delta P circulators, and those need input to make a decision as well. And the input those receive has to do with changes within the system. Hydraulic characteristic changes, like when zone valves open and close and things like that. That is how the circulator actually feels what's happening within the system. And again, we'll give you enough information to understand that, when to make a good decision on which one to use. Let's focus in on delta P, or pressure differential circulators. Now, the first thing people are going to think is that these things have pressure sensors in them, and they don't. We've talked about that for a few years now. Just a general understanding is that the motor data, so understand if the impeller that's within the fluid is connected to a shaft and the shaft is connected to the motor, then anything that happens hydraulically within the system, that motor is going to feel. Okay, so those hydraulic pressure changes within the system are felt by the motor, and that's how the motor knows what to do. Generally speaking, this applies to everybody's product, not just Taco. I mean, these are general applications of a delta P ECM. Okay. Another thing to look at is that these some people call them control curves or operating ranges. I'll point out over here, see this fat dotted line here, this fat dotted line here, and this one would be an actual curve, but these are actually operating ranges, because what we're doing when we're in these automatic modes is we're actually telling the circulator what we want it to do. So we're kind of giving it a guideline to run on. And so I like to call that an operating range, or some people call it a control curve. The other thing to understand, remember I said there's 3 to 5 different operating modes. Well, the 3 are the basic offering that's out there in most everybody's product. In one sense or another, you're going to get something with constant pressure. Okay, and we'll go into that. We'll make sure you understand what constant pressure is and when to use it. Then you have proportional pressure. These are 2 automatic modes. And then you'll get some kind of fixed speed. A lot of people just give you the good old 3 speeds. Some might have a little more. I've seen some that are like 7 speeds and things like that. Taco does a little bit different, but generally speaking, again, this applies to everybody's product. So again, we're going to focus in on these and kind of expand on some of it to make sure you know when to use those modes of operation. Again, it can be confusing. If you look here, here's 5, a total of 5. We got the constant pressure. We'll change this to fixed speed. We'll call this proportional pressure. Here's your automatic adaptable modes. And here's a third-party control that we'll call 0 to 10. And we'll get into that a little bit and show you when that's applicable as well. So again, giving you enough information to understand when to use these modes is what we're all about here this evening. So understand this about the modes of operation as well, that some of the modes are manual, right? And some of the modes are automatic. Okay, I can have a fancy ECM, pull it out of the box, it does all kinds of tricks, but guess what? There's plenty of opportunity and times when it's appropriate to take that automatic mode out, put it back into a manual fixed speed mode, and let the pump operate the way it's supposed to. So, people will think, oh, I paid extra money and I have all these features and benefits. Yes, you do, but that doesn't mean that they're applicable for your particular job or particular application that you're about to, commission the circulator on. So, anyways, just remember, some are manual and some are automatic. And I'm going to give you, like I said, I'm going to give you a bunch of drawings. Up in the right-hand corner of these drawings is where I'm going to give you some icons. This will be the one for something that's manually controlled. And of course, this will be the one for the automatic control. So just remember to look up here in the upper right-hand corner, and you'll see, because I'm going to talk about a lot of things and I'll be changing drawings and that sort of thing. And if you get lost or you want to just go back and check and see what mode I'm talking about, just look up in the upper right-hand corner, and that'll help you remember all that good stuff. So like for instance, here's a fixed speed, and understand that it's a manual, because I'm going to talk about the good old single speed, permanent split capacitor circulators that we've been using for 50 some odd years, right? So remember, this had a maximum speed. It just ran out of speed. Okay, it was a single speed application in this case. Doesn't matter if it could have 3 lines down here, then it was a 3-speed pump, but it's still only going to run on this monorail, right? It can't run over here and it can't run down here. It's going to run where that line is. So it's a good way to understand that. But understand when we step into ECM world, things change quite a bit. We still have a maximum speed, as you can see here. I can run up and down here. And I have this minimum speed, this other bold line that's down here. But what's more importantly is I have all these subsequent lower RPMs that the circulator can run at. Notice I'm not showing you a specific circulator. This is just understanding how an ECM performance curve looks. You have lots of opportunity here, and this is the fixed speed mode is the one where you want to use that. So anyway, fixed speed function, we want to make sure that you understand when you're changing speed on a fixed speed application. I want you to know what happens to this thing that we call the operating point. That's what this is right here. We'll say, let's just say, for instance, that on this particular system, you have it at maximum speed and all the zones are open, and that's where it's running. And then you're going to have zones begin to close as the zones are satisfied, things start to shut off. And it's just going to, well, let me clarify something. In this case, we're going to talk about a zone circulator when there's not zones closing. It's going to run right there. If that happens to be too many GPM, you can see right here, it's a slightly more than 14, and I wanted to turn it down. Watch what it does if I turn it down. Now I'm going to get this particular GPM. Notice as I slow it down, it follows this system resistance curve all the way down. If I were to turn it all the way down here, it's going to run right here. But I want you to have a visual understanding of what it's doing as I'm turning the pump down in fixed speed mode. I got ahead of myself in that, in this case, this is not an automatic mode. It's not going to change by itself. You're going to actually tell it what to do, but I want to give you that visual understanding of what it does in a zone pump application. And just to go along with that, here's a quick little sketch showing a conventional cast iron boiler with 3 zone circulators on it, okay? Pumping out this direction, coming back on return, and you can see what it's doing here. Now, understanding that the downstream of a zone circulator, you won't have zone valves open and closing, is a good way to understand that that is gives you all the reason to stay in a fixed speed mode. Remember what I said about the inputs, okay? So keep, you know, as I'm continue talking, go back and remember that the circulator needs an input in order to make a decision if it's going to do something automatically, okay? So zone pumping kind of takes that out of the equation. If I have nothing downstream, you know, no zone valves or thermostatic radiator valves or anything downstream that's going to open and close, then the circulator is not going to see any hydraulic changes, and therefore it's going to stay at whatever it's at. If it's in one of those automatic modes, it's going to run at the factory preset position, and that's all it's going to do unless you've told it to do something different. So, and believe me, there's a whole bunch of circulators out doing that right now, okay, that they just didn't understand the changes that have to happen in order for a pump to automatically change, okay? I'm going to put some little check marks by these, understanding that zone pumping is appropriate for fixed speed application. So any questions so far?
And we just had one question come up about our boiler companies using these circulators on their boilers. And that was from Stanley Hill. And yeah, we are seeing a lot of the boiler companies putting the 007E on their boilers instead of the 007.
Yep.
And we'll get into what the 007E is, but it's basically an ECM version of the 007, no programming or dials or switches or anything.
Yeah, very good. And it'll find its happy spot right along. Those come out of the box in constant pressure, and they're not expected to make any changes. They just they look and interpret whether it's going to give them enough flow under that setting. And we'll talk about that a little bit when we get into that. So
there's one really good question from Richard J, and I think this is a very important point to make, and it's a real obvious one. Why would you use the ECM in this application? If you are using if there's no pressure changes, no pressure differential changes in the system, why would you use an ECM circulator as a zone pump? I think
I'd
that's a
love to
great
answer that.
question. That's a
I'd
great
love to answer
question.
that. Yeah. Well, the good thing that I made note of is under the fixed speed mode of these ECMs, uh, we have the ability now to take the circulator and turn it down to the appropriate RPM that gives you the GPM that you want with a fixed speed. And maybe if it's 3 speeds, you have some choices there. In fact, last week we had a great session on 3-speed circulators. Don't get me wrong, there's still places for that. But there's a whole lot of other things we get with ECM, especially some of the ones that Takeo sells as it relates to circulators that kind of take care of themselves, right? If there ever is an issue from the standpoint of something blocking it, and it kind of breaks itself free. The other thing that we have is a nice little min-max dial on many of the models, where now we can turn the circulator down to a more appropriate zone pump flow characteristic, right? So many times we'll see a wall full of 007s or a wall full of 1558s. Guess what, folks? Even on low speed and even at that relatively small pump, we're over pumping the hell out of that system. So my answer to that question is ECM gives you much more flexibility, not to mention all the other feature and benefit that comes along with it. So
Yeah, last week we talked about the dangers and the problems of over pumping. And if we have the ability with an ECM circulator, the 0018E, for example, to dial that thing down to, hey, I need 2.5 gallons a minute at 5 feet ahead max. That's what I want, and I'll set that up to do that. I have to know how to do it. It's not going to do it by itself, but I have the ability to set it up so it's sized appropriately for the application, and that's the biggest thing, because over pumping is just a serious chronic issue that we have here in our industry.
Yeah, I've seen systems that have a requirement of about 150,000 BTUs with a pumping power of about 500,000. So just think about it. Okay, so that's things to consider. Okay. Let's see where we're at here. Still talking about fixed speed. Again, look up here in the upper right-hand corner. Now I'll talk about this one right here. Notice this circulator is in what we'll call a system pump application, because downstream it's got 3 zones here, right? So I'm not going to want to use that in a fixed speed mode, so I'm going to put a red X on there. Let's move down to something like domestic hot water generation. We're pulling water out of the heat exchanger, right? Pumping it through. This is the circuitry for this through this heat exchanger, right? We're back up here and we're back into the boiler at this point in time. Now, if you look at that, and again, that's what we want to encourage you to do. Look at the system. Are there any valves that are automatically going to open and close to give this circulator, remember this is a delta P circulator that we're talking about right now, to give it any of the input it needs to make a decision to change its RPMs? And the answer, of course, is no. So fixed speed is still the appropriate mode of operation for that. Even if it has all the bells and whistles, take that out, put it in fixed speed. And we typically tell you to run it at maximum speed for a few minutes and then appropriately turn it down to what it needs to be. In this case, depending on how close the circulator was to the correct size at maximum speed, I would just leave it at maximum speed. The idea and the concept is here, let's make as much hot water as quickly as we can and shut everything back off again. This is showing a boiler primary. Some people say, hey, let's not get into the primary secondary thing. Let's just call it the boiler pump, okay? This, you can see that the duty of this particular circulator is nothing more than pushing water through the heat exchanger, down through these closely spaced T's and back, right? That's the responsibility of that circulator, and that's it, okay? Now notice I've got check marks by these zone pumps already in this application. So I am saying that, generally speaking, in a ModCon boiler application, a fixed speed mode would be correct. That where we want to really sharpen our pencil here is do the right thing when it comes to sizing and calculating the GPM requirement for this particular application. We've done some classes on this where we'll go through and show you to look at this manufacturer's documentation at the back of the book. Typically in the back of the installation manual, they give you the pressure drop curve so that you can go in and say, do a couple things. See what is the minimum flow to make sure that you give that boiler enough, but also the kind of the, you know, the carte blanche to be able to turn that circulator down. We've found as the years have gone by that by running the circulator at a lower speed will tend to give you lower return temperatures back to the boiler's heat exchangers, thus increasing the overall efficiency that this system can bring. The boiler's going to condense better the lower the return temperatures are, and everybody's going to be happier. One of the ways that we do that is by not oversizing this pump. So what we want to do when we're talking about sharpening the pencil is in that universal hydronic formula, we want to make sure the temperature differential that you use is the maximum that that particular manufacturer will allow you to use. Okay. And again, I'm going to get into another way that we can control this circulator as well. But right now, just understand that that general rule. Okay, fixed speed is the most appropriate if we don't have what we're going to talk about next. Now, with that said, John, did something pop up that I should, before I switch slides here, or are we good?
Well, there was one question. I think you are going to, you will be addressing this. It's from Jeremy Nash. With a 0 to 10 volt pump that receives its ramp up and ramp down orders from a third-party device, when it is used on a primary loop or the boiler loop, what is the issue when you are running a 3-speed pump on the secondary loop set to the system flow requirements if you're not using a hydraulic separator? What are the possible negative interactions between the primary and the secondary loops in this case?
Well, let's go ahead, because that's you know, so I get a check mark here. That's the next slides kind of goes into that. Notice I've changed up here, right? I'm in an automatic. Well, it's automatic based on what the third party is going to tell us. So I think I can answer this question. You know, let me go into this slide. Maybe it'll answer it. If not, I'll expound a little bit more. But notice what I've drawn in here. I've got what's shown as a control wire. This is not the line voltage that tells the circulator to come on and off. That's inferred. That's going to be there anyway. What we're talking about now is if the boiler manufacturer has something like a 0 to 10 or you know, 4 to 20 or something along those lines that's meant to control the circulator for itself. You know, remember this, there's nothing this circulator has a responsibility for than just this boiler's heat exchanger. Okay, so if they have that output and the circulator has the ability to receive that output as kind of marching orders, then you have a very good, you know, kind of you know, dovetail together from a pumping and control standpoint. This is a good way to go. But again, if the pump doesn't have it, or the boiler manufacturer doesn't have it, then you can't do that. Then we go back to a more appropriately sized fixed speed application. On 0 to 10, typically what they'll do is, and each manufacturer is probably a little different, but the ones that probably have done a pretty good job with this are basing the speed of this circulator on a fixed temperature differential across that piece of equipment. For instance, I go into the control module of this boiler and it gives me a default setting somewhere in the range of about a 30-degree delta T. And they'll tell you what you can go out to and what you should tighten up to. And you could set that to whatever you want. And again, it just looks, the boilers, the ModCon boilers will have return and supply sensors that read the temperatures across the boiler's heat exchanger. And they monitor that, right? So that now they can give a signal, in this case, 0 to 10, out to this pump to spin the pump up or down, you know, speed it up or slow it down to maintain that desired temperature differential across that piece of equipment. And again, on most modulating condensing pieces of equipment, the bigger that delta T is, the better, because what we're trying to do is get the lowest return temperature back. Now, as far as how that affects anything, let's say that these were traditional 3-speed circulators set on a fixed speed, that doesn't have really anything to do, and they won't fight with each other, or they won't affect each other as long as you followed the rules that we won't get into tonight. But this is your closely spaced tees, maximum spacing of 4 pipe diameters between the two. What that means is not to measure 4 pipe diameters. It means to put these tees as closely together as you could possibly get them, depending on how the connections are made. Okay.
I think the only issue that I'm sorry, Rick, go ahead.
Well, I'm just saying we'll have hydraulic isolation there. This circulator is doing nothing more than injecting energy into this tee. And these circulators will take whatever's injected there and go out. There is a possibility that these pumps are running so slow and this pump can't go any lower than low, and you'll get a little bit of cross of the kind of reverse flow of the heated water back into the boiler's heat exchanger. That's kind of a no-no, but in bench conditions and when you're not at design conditions, you're going to get a little of that, especially on a single speed application. So go ahead, John. Go ahead and comment.
The concern as the other end would be if the system circulators were again set to contractor no callback mode, and we had they were dramatically oversized, we would have a pretty snug supply and return delta T
across the system. Yes,
across the system, and the water coming back from the system that the boiler pump has to pump into the boiler is going to be higher than you'd like.
Yeah.
And then that pump's going to ramp way the heck down. Yep. And you've got whether that causes an issue or not, it's going to be how, in terms of boiler short cycling, it's hard to tell.
It's hard to tell, but that also brings up the point that whoever did that didn't understand what the consequences of running those pumps at higher speeds. And again, we teach on this weekly. So folks, read up, thank you for attending. You're going to learn stuff like this and how to more appropriately set those fixed speed pumps if that's what you're doing. So anyway, let's move on. More of the same. Notice I'm still up here in fixed speed, but this is just kind of showing you a no here, okay? But you can see on this one, I've already said, hey, yeah, we'll put a check mark there and there. Again, I'm trying to give you a bunch of different scenarios to show you, because what I want you to get out of this is at midnight on New Year's Eve, if you go out to change a circulator and you happen to have a newer ECM, hopefully a nice Takeo pump in your hand, you'll get it set up in the appropriate mode without doing a bunch of numbers and math and all that stuff. We just want you to take a glance at the system, and I think this will help you understand, especially when I get into the next couple of slides that talk about the automatic modes of operation. Well, starting here at constant pressure, okay, now we're automatic mode, constant pressure. We're going to put that same operating point here that I showed you before. Now let's see what happens if I have a system that's running. Let's say this is a system pump with zone valves fairly close to the system pump. We'll call that a home run. We'll get into that a little bit. But if those zone valves start to close, what happens to the operating point? So visualize. And this is great because we actually, Dave, at the end of this, Dave Holdorf is going to show you what we can do from the standpoint of having a Bluetooth app that actually shows this. I mean, we've been using these kind of cartoon characters for a long time, many years now, showing you what's going to happen, and hopefully we're getting you to envision what's actually invisible in the background of these hydronic systems. But Dave will get a chance to share that. So watch what happens when the first zone valve closes under this operating point. Now see that little bump? You saw it jump up and come back down. Well, traditionally on a fixed speed pump, that's what happens. You probably sat through pump classes before where we showed you as we close zone valves, it just starts working its way up this single speed application. Well, this tends to want to do the same thing hydraulically, but the motor recognizes and it pulls itself back down here. Okay, so let's do it a couple more times so you see and you get an idea of what this thing's doing in the background. It feels those zone valves closing, it feels what's going on and the hydraulic changes that are happening, and it's doing a good job of exactly what we told it to do. In this case, if you look at the application here, we said constant pressure mode. This stayed right and hung right in there at 10 foot of differential, right? And this did exactly what we wanted it to do. And that's just a visual understanding of what the circulator is doing in there. Again, an automatic mode in the constant pressure. So let's
Hey,
get
Rick?
into the, yeah, go ahead.
Just go back up a slide there a second.
Sure.
So depending on everybody's system and their video that they can get in, they may not have seen the your bump, your dot go up, because sometimes the animations that you and I do on our presentations and when we do these live, you can actually see that. Online, sometimes it's a little slower. You just might all of a sudden see the dot move from the right to the left. What happens is it actually goes up. It follows the curve.
Yep.
All right. So that's what it does, right? We talked about this in the last couple of weeks where circulators are always going to follow the curve.
Yep.
Right. So it's going to go up. So it starts to go up a little bit, and then it says, no, don't want to operate there, and it's going to bop down a couple other lines. So Rick has that animation, so it shows it how it does it, but it goes from curve to curve to curve to curve to get back to the 10 foot, right? Because as your flow decreases, your head always goes up if it's following the curve. And so then it says, no, I don't want to be up there, and it drops down to a different circulator curve. I hope that makes sense to everybody.
Well, and I'm sorry that you're not seeing the animation. It took me a long time to do that. John, you can relate to that.
I can see it just fine. I don't know. I could maybe good
Okay.
internet.
Hopefully half of your
I was following the bouncing ball, like
That's what I
it
want
was
you
the
to
Lawrence
do.
Welk show here for a minute.
Follow the
Some
bouncing
do, some don't.
ball.
I just some webinars that I've been going on to, sometimes you see the animation, sometimes you don't. I just wanted to make sure with the tons of people that we have here that everybody understands what happens too. So,
All right, very
excellent.
good.
Move
Thanks for
along.
the
Sorry, sir.
clarification.
Keep on going.
All right. So let's use terminology within our industry. Home run just means nothing more that, excuse me, home is where the near boiler piping is. In this case, you can see that I've got a system pump. I've got 3 zone valves. I keep it to 3 for simplicity. I want to make this drawing as big as I can to show detail. So just imagine 7 zones if you want. It doesn't matter. So 3 zones, system pump. You can see that I have 3 supplies. These are my zone valves that are out on supply, pumps pumping this direction. And I have 3 returns, corresponding returns to those 3 supplies. And they all have paralleled supplies and returns out to the terminal units. Notice I'm not going to get particular, okay? It could be a manifold with loops on it. It could be air handling units. It could be series runs of baseboard. Doesn't really matter, okay? What matters is that I have a supply and a return that parallel back to the near boiler area. We'll call that home, hence the name home run. Okay, so this is a very popular North American piping scheme. Okay, with that in mind, notice what mode I'm in. Okay, and it will, just understand if you've sat through any of the classes where we talk about how to estimate what the pressure drop is, we never tie zone 1, 2, and 3 together as far as the pressure drop is concerned. Of course, the GPM for each zone is cumulative, but we always grab the worst case. So that should be your indicator to say, hey, do I ever want to be able to satisfy that one worst case zone on the design day? And the answer should always be yes. So if you want to be able to satisfy the worst pressure drop scenario on your 3 or 5 or 7 zones, then you've got to understand that constant pressure is a better way to control that. Okay, so again, let's give you a check mark here. Okay, and over here we'll give you a big red X. Okay, again, we already talked about this. And because I have multiple circs on this drawing, I'm going to go ahead and mention each one of them. So,
a good question here for you, Rick.
Go ahead.
From Chris Lamont. Are there pressure sensors, typically static sensors, that do not protrude into the pipe? Are total pressure sensors ever used? I think he's trying to get at how does the circulator know the pressure differential? And the answer is we don't use pressure sensors. None of them have pressure sensors.
Well, there's a circulator on the market that's a full-blown commercial, application that actually has tried to do that, but has not had that well of success, because we know in this industry that we have nasty water. We
Yeah.
got dirty water. John, sing it to me.
Love that dirty water.
Yeah. And the little capillary tubes that they use to take those pressure readings off tend to plug up. And in fact, I've got that from several sources that sell those products, and that's problematic. What most ECM manufacturers use is just the information off the motor. And I think I alluded to that earlier, that the motor is feeling the hydraulic changes. Therefore, we do not need a pressure sensor within the system.
Right, because sensors fail, right?
Sensors have problems.
Basically what it's doing is, let's say I've got 3 zones open and the pump is pumping along at a 10-foot ahead constant pressure setting, and a zone valve closes. All of a sudden, the impeller is spinning against a little bit more resistance.
Correct.
Well, the brain senses that. It senses that we're going up on that pump curve,
Yep.
right? And the amp draw changes, et cetera. And the pump's brain says, that's not right. And it'll automatically drop down to the correct new pump curve, running slower. So we have a constant pressure differential. Another zone valve closes, we go up, boom. That's that bouncing ball that Rick had. It's sensing we're pumping against a greater pressure differential, more resistance. So boom, it drops down again.
Yep.
And it's all done by algorithms and math programming in the brain, but it's automatic, and there are no sensors inside.
Yeah, good.
Right. Let me
Good
just, I want to show you guys real quick. I've got one here I took apart. The only thing that's missing right now is the casing. All right, your volute. So if we go and take out the cartridge here, there's nothing sensitive in there.
Yeah.
All right. All you see is a hunk of injection mold, and then seated all the way down in there is your graphite bearing. That's all the way down at the bottom that holds onto the shaft. So that's it. No pressure sensors, no PFM, no magic, no anything. So here's your anatomy. All right. The black stripe here, this is your motor. That's it. That's the size of the motor. That's the windings. This green section here has a circuit board in here, all right, where your power ties into, okay, and just transfer the power to the windings on top of the motor. So, and actually I got, sorry, forgot about this. So as we take a look at one of the motors here, the circuit board just lands right onto one of these 4 points, and these are your windings. All right, and it knows what to do, and it tells it what the circulator to do from there on. All right, that's it. That's your manufacturing behind it.
Very good. Good. Just another look at home run. This is popular out there. Siegenthaler has written some stuff like that. The concept of using a panel radiator or panel rad with individual supplies and returns out to that. Notice no thermostatic radiator valve. Notice that the zoning is back here on the manifold in this case. Okay, so we've got these actuators that open close that are on call from a thermostat that's in the room that has this particular panel rad in it, or multiples, right? But notice what we're getting at is we have an individual supply and an individual return coming all the way from the terminal unit back to near the boiler or home. Okay, again, now when we did the calculation, we would have looked at all 6 of these panel rads, right? We would have looked at them and we would have done a calculation to say which one is the worst case. Okay, not necessarily the biggest one, but depending on how long the run was, lots of variables in there. But understand that one of them would have set the precedent that this circulator has to be able to overcome in a design condition to satisfy that zone. And that's why we look to constant pressure to say that would be the correct mode of operation for this particular application. Therefore, we'll give it a nice green check mark, and we'll put the red X right across this one. So again, just talking about, again, we told you we're going to show you pictures. This hopefully it's worth 1,000 words, even though I'm trying to cram them in there, but you'll get my point, hopefully. So let's go ahead and move to proportional pressure. Again, this is kind of the mystery mode, and we want to demystify this as much as we can. Notice the name proportional. That struck me, when I had to start selling pumps, and said, I need to know more about what that's all about, because in my view, when I started looking at the performance curve, I said, well, what's proportional about this? There's really nothing proportional about it until I looked a little closer. And so hopefully I can tell you what I'm getting at. But let's start at the same point here. Here's the operating range that we had spoken about. Same place we've been starting. Okay. Now let's pretend that all the valves are open. It's running out here at maximum speed, and we begin to close thermostatic radiator valves, or we begin to close zone valves, or whatever within the system, right? So as that happens, it gets that little hop again. But notice what it's doing that's a little bit different than what I showed you before. It's still moving, right? It's getting that little hop, and it's moving from the right to the left. But notice what I've illustrated here. It's moving down in a trajectory that's at a specific, hence the name, proportion. Okay, from the manufacturer like Takeo, we write a code in this thing that says, what it is. And here's a real simple thing I'll show you here. And, we started teaching this many years ago, probably about 6 years ago, so that people would have a good understanding what it means when you're talking about proportional pressure. Now, any of you out there listening and watching, I want you to understand you can look at any manufacturer's proportional curve and get an idea of the algorithm that's written in the background of it. You can simply look down here at 0 GPM and make a point here of what it is. In this case, it's about 3.8 or whatever. And then you look at it where this line, you follow it all the way over here to where it meets just slightly above 6 feet ahead. And there's a ratio between those two numbers. So that's what we're saying. It's proportional to the pitch of these things. So you can take anybody's product. So I'll put the numbers up there for you, and I think you'll see where I'm going. Okay, 3.6 down here divided by 6.2 up here gives me a 0.58. 6.2 here divided by 10.7 here gives me a 5/8, so on and so forth. And you can see that this particular circulator had an algorithm written in it that said, thou shalt move from right to left and shall drop at about a 58% proportion. Okay, so that's all they're really doing. They are looking at kind of an inferred GPM, and they're making some decisions like that. But all in all, the simplified way to look at this is that it's dropping at a particular pitch. Now, hopefully that helps you understand the whole thing about proportional pressure. So let's get into the piping configurations that are most appropriate for proportional pressure. Now, I'm standing in a mechanical room again. I'll show it first in like an atmospheric cast iron application. These little continuation marks are just the typical Z's that you see that show separation, right? And let's pretend that those are escutcheons on the wall. Okay, I'm standing in a mechanical room. I'm looking at one big pipe going out to the system. I'm looking at one big pipe coming back from the system. And I know, because I've walked the job, that there's multiple zones out there, right? We know there's zone valves, there's things, or thermostatic radiator valves or whatever. But the difference between this extended header system and a home run is evident, isn't it? You can see that there's not single supplies and returns that are coming back to the boiler room. There's one big extended header that goes out, and then out in the building is where your takeoffs are to serve those zones. Okay. Now understand that when we design this circulator, we have to assume the worst case. We have to go for a design condition. That means that all of these zones are open and there's a whole bunch of flow, and that flow has a whole lot creates a whole lot of resistance in the supply and return piping that's out in as part of the extended header. Now, as we close these zone valves, say they get satisfied, say it starts warming up on the south side in the morning or something, then what we'll see is the circulator, of course, will feel those zone valves closing it will slow down. It'll lessen the GPM, and therefore, proportionally, we can drop the expected amount of resistance within that extended header. Hopefully that's making sense to you. I'll actually do a little calculation for you here in just a minute that'll help you nail that down. But I think conceptually you'll get an idea of why proportional pressure works better for those systems that have extended headers in them. Any questions so far, folks?
Yeah, Bob Dresser said, basically point out that's a two-pipe system throughout, correct? It's your
That's a
basic
two-pipe, yeah,
direct-
two-pipe direct return, yes.
two-pipe direct return, and it will be similar, I think, in your next slide on a reverse return as well.
Correct.
And Rodney says this would be viable on larger commercial systems. You won't see this in a house.
Yes, we
probably.
do. Yeah, yes, we do.
Mhm.
Trophy homes, 30,000 square feet, 20,000
okay.
square feet, etc. Yeah, we see homes with this, but I will give you this, that those are basically small commercial applications. So
Right.
yeah, I think we're all right on that. So,
All right,
okay.
very good.
All right, very good. So, so we've got system circulator here. Notice here's the discussion leaving the mechanical room, and then we have going out. And again, this is reverse return in a two-pipe reverse return. Again, I'm just showing you because it's simpler to draw with zone valves and element. So I'm doing a baseboard. It could be a fan coil. It could be. Doesn't matter what the terminal unit is because we need to do a calculation on it anyway. But I think the reason I originally drew this up because there was another misunderstanding out there in the world of ECMs that they said that the ECM is a self-balancing circulator. Well, what does that lead you to believe? Does that lead you to believe I can go back to do something like this and not worry about balancing? No. Okay, the circulator doesn't have anything to do with balancing. Okay, get your arms around that. What they meant when they said that, they weren't making a wrong statement. And I say they were saying that now with the ECMs, we don't have to do the initial balance where we used to impart false resistance against the circulator to get it to ride in a more appropriate spot on the performance curve. That's more of a commercial thing, but people in the residential world were doing it as well. So that's what I'm just dispelling that misunderstanding, hopefully. So, all right. Here's where it all started. This kind of comes across the pond this way. We had the initial ModCon wall hung boilers. We were introduced to hydraulic separators or low loss headers and things like that. And then across the pond, they love the panel radiators, thermostatic radiator valves. In this case, we've got mains, we got branches, we got twigs. Okay, and basically. It's this in a nutshell. You got a whole lot of extended piping out into the system one way or another that's not part of the mechanical room. You're probably about 98% assured that proportional pressure will be the right one. Okay, so again, that we're just throwing a bunch of drawings at you, but showing you these modes of operation that make the most sense. And again, we haven't done a lot of math here, right? We're not calculating every little job, which you're not typically going to do at midnight on New Year's Eve. I think I made that point. Okay, so but this would be an extended header, and again, these the algorithms and the modes of operation, these adaptable auto modes and everything that we're about to talk about came to us from across the pond. They're very used to this kind of piping, but it just almost, it's just, we're not doing this a whole lot in North America. We just do things differently. And so a lot of the things that they set up for their systems across the pond aren't necessarily the right modes of operation for North America. Again, there's a time and a place for everything. Reminds me of a song, but again, understand just at a glance how to perceive what mode of operation is going to be right for these. Again, I'll put my check mark here, and I'll put the red X here. Now, any questions before I move on?
Yeah, there are a couple. Let's see. Well, one was, does a reverse return gain something over a two-pipe system? Well, a reverse return is a kind of a two-pipe system.
Yeah.
It's a reverse return two-pipe versus a direct return two-pipe system. And
Good.
reverse return is simply it's kind of almost sort of self-balancing in the respect that each individual loop is the same length in theory.
In theory.
Whereas a direct return, it's like first supplied is the first one returned. You would need more aggressive flow balancing on each terminal unit
Yep.
or each branch in a direct return two-pipe.
Cool. Agreed. So here's a little calculation. Let's do this together, and this might gel for you a little bit better.
One more question, which is a really good one from Zach DeVoy. If you have Wurzbo telestats in the system controlling individual loops, do we stay with constant pressure or move to proportional pressure?
Do you have an extended header that's going out and feeding those manifold locations?
All right, that would be the determining factor. If it's all in a mechanical room and the pump's right there, and it's essentially what you're describing there, if I can infer, Zach, is it's a zone valve system, right? A telestat is a zone valve. All right. In that respect, I would say if it's just a typical radiant system and you have your manifold and the pump's right there and you're controlling your zones with those telestats, it's a zone valve system. So constant pressure is definitely the way to go. Proportional pressure might very well get you into some trouble.
I would not knowing what it looks like. And again, this realistically, we're trying to give you information based on not doing the math, even though we're probably the kings of telling you to do the math. We understand there's times and situations where you can't. I would say my answer to that question is, where are those manifolds located and how are they being supplied? If you've got a dedicated supply and return that parallel back on a home run to the mechanical room, then constant pressure would be correct. If it's an extended header system that goes out and picks up those manifolds, regardless if they're telestats, then most likely, if you actually looked at the calculation, there's more pressure drop in the extended header than there is in the manifold itself. Therefore, as you reduce flow out in that extended header, you can proportionally drop the pressure. So again, that's where you kind of you got to know more about the system to make an exact decision. So.
Geez, I love that kind of talk, Rick.
Oh man.
Isn't he good? I just want to stop right here, guys. Isn't he good? I'm telling you, he's good.
Shucks.
He is just so good.
No, I'm trying to walk a tightrope. You know what I'm saying?
So we'll call you Walenda, okay? Go ahead.
All right, so let's put some numbers after this. You folks have already seen this, right? So let's just put some numbers to it. This is like a heavy residential, light commercial application. Okay, so I did the calculations, right? I looked at all this. I know how much GPM I need. I know what my pressure drop is at that terminal unit, and I've now gone round robin and I've looked at this and said, hey, okay, this is the job. Okay, but this isn't everything. Which one of you, real quick, send in an answer. I can't see it. Dave and John can see it. Which one of these is the worst case in this particular application? Which one of these terminal units is going to present the most issue to the circulator that the circulator has to overcome?
Yep, we see him coming in at 12 feet, 9 gallons a minute at 12 foot ahead.
There you go, baby. And for the sake of time, I'm just going to go for it. But keep those answers coming. So understanding that, I know that on a design day, I better make sure that circulator can do 9 GPM at 12 foot ahead, right? But that's not everything the circulator has to do. Doesn't the circulator have to worry about all this extended header? Yes, it does, right? So, and supply and return, okay? So this is kind of how it lays out. I did the calc for you. I added all the GPM, but we need 75 gallons a minute, okay? And I need more than 12, right? So here's kind of one of the little things that'll help you make a good decision, okay? Once you've calculated what the actual pressure drop is under a design condition of the extended header, that'll help you make a good decision here. So in this case, I calculated it out. I need 18 foot ahead just to take care of that extended header, and I need a little incidental 2 foot ahead at the near boiler piping. And that's just from this point to this point. That's just this stuff here, right? This near boiler. We got an air separator, magnetic dirt separator, some T's, some incidentals, okay? Now notice this. Is this number higher than this number? And if it is, in this case, yes, most likely proportional pressure is the right way, regardless of what the terminal unit is or how it's configured. Okay, so again, that's just doing calculations over and over again and getting a sense of how this kind of works. Okay, so we need 75 gallons a minute at 32 foot ahead. Let's show you what that looks like on one of our curves. Here's our operating, here's our Q, okay. This is the quantity of the GPM that I'm pumping, so 75 gallons a minute comes up here to 32 foot ahead. Now, I'm doing this to show you what this proportional pressure curve is going to do. How do I get this set up correctly? Well, you listen to what I'm saying here. You're not going to set it at 32 foot ahead. You're going to set it, go back to what I was telling you earlier, is you follow it up to the maximum speed. Notice the maximum speed here is 36 feet. So I'm going to set it at 36 feet. At a 50% proportion, it's going to intersect right with your operating point. And now this thing, if you did your design correctly, is going to take from this point here, and it's going to roll up and down this proportion here and give you exactly what you want. The only other thing you have to recall and remember is that even when it starts working down here at real low GPMs, it still has to be able to overcome the worst case scenario, and we can. You know, if you remember, what was it, 9 at 12? So this is 5, 10, you go right up here, we're above 12 foot ahead. So we know that this setting would be appropriate for that particular proportional pressure application. Any questions on that, and then we can move on?
Nope, I think you nailed it.
Okay, great. This is near and dear to John's heart here. So again, we got to dispel this, and then I'll hand the con over to Dave Holdorf. But understand that when these first came out, they came out with these adaptive automatic modes that everybody thought was the coolest thing since sliced bread. And they are cool. I'm not going to take anything away from that. We have them. They have them. In fact, I'm going to list a bunch of them here. But guess what? They're seldom, in North America, they're seldom the right mode to use. You have to be able to put several things together in order to agree that now that's the right mode. Now understand that this is the mode that most of these ECMs come out of the box in. So you have to know how to take them out of that mode and put them in a more appropriate mode. And that's what this session was all about. Hopefully you got that, right? These are not smart pumps. We don't use that term. They're not any smarter than any other pump or circulator. Again, you got to know something about your system, and that's why we're giving you this information, okay? Adaptable type auto modes are out there. Taco's got active adapt. Taco's got an auto mode in their more commercial applications. Grundfos's auto adapt. Velo's got dynamic adapt that's out there. Armstrong just calls it auto like we do up here. Again, everybody's got something, right? We want you to know when to use it, and more importantly, when not to use it, okay? You got to remember that this is the biggest mistake that most people have made with other brands, is they forget that it has this wedge of operating condition. And if your requirements of GPM and head don't fall within the shaded area, you can't use the auto mode, okay? If you want the system to work appropriately, okay? So don't make that mistake, and a whole bunch of people have, okay? The other thing to understand is what we just spent a bunch of time on. Your piping configuration has to support something that's proportional pressure, okay? So if your piping system is home run and most of the automatic modes are proportional, then don't use them. That's not the right thing to do, okay? Understand that the proportional slopes are a little bit different. I'll show you real quick here for the sake of time that when you have a fat back end here, notice this wedge is shaped like this, but it comes back and it's kind of fat here, and this one over here is peaked. The only difference is these are fixed proportions, and this is a variable proportion. In this case, some of the Taco circulators in the commercial offering go from 50% up to 70% proportion. And you can tell that by looking at the back end of the pitch here. If they're nice and fat like this, then they're fixed at say 50%. 50% is probably the most popular, and everybody's somewhere in and around 50%. Another thing to realize that these proportional automatic adaptable modes, since they're primarily meant to run long periods of time before they ever make a decision to change its speed, right? So unless you're doing zone synchronization, zone staggering, or complete continuous circulation, these modes don't make a lot of sense for you. You know, if your zone's only going to call for 10 or 15 minutes and then shut back off again, a lot of these modes never have enough time to make a decision whether to change their original middle, where they come out of the box and they just kind of run in the middle of that wedge of operating condition, right in the middle, and then they have time to change. So a lot of people are setting these things up thinking they're getting something they're not, and that's been most of the story in my experience. The other thing to acknowledge is their delta P, right? If they need pressure differentials in the system to change in order to get that input to make a decision to change, don't put it as a boiler pump. Don't use these modes as zone pumping, et cetera, et cetera, et cetera. I mean, I'll give you just, several ideas here of where these have been misused, okay? Unit heaters, right? Single fan coils, boiler pumps, heat exchangers. Again, those adaptable automatic proportional modes make no sense in those applications.
Rick, you could probably include a lot of radiant floor heating applications there as well, where the flow and head requirements are above that wedge. We see that an awful lot where
absolutely, yeah.
They put it in this auto mode and it doesn't do anything, and because, like as you mentioned, we're outside the wedge. It's just not going to.
We're not living in the wedge. Folks, Taco's got a whole bunch of ECM offering, and I'm gonna hand it over to Dave here in a bit to show you some of the cool things we're doing. But just as a real quick introduction, this is a circulator that we just kind of released, this 0026E, and you folks that haven't got to sit through one of these, please, we're doing them. Every one of our reps are doing them. We're doing them. We've done the initial release of this product. This is kind of, we'll call a tweener. It's in between a pump that we released over here. Notice this 0034, and so we've done. We're actually examining the systems out there and finding out where we need to kind of fill in some blanks, and this is kind of what we're doing with the 0026. And then within a month or two, I'll give a little flexibility there. We're actually going to really open up the sky and let it rain stainless steel circulator. So you're going to see a 007E, 0015E3, and a 0018E with all the features you're already familiar with in a cast iron flange product. It's going to be available in a stainless steel universal flange as well as a BSP half union set. And so just introduction, heads up on that. Keep your eyes and ears open for that. I'm going to turn it back over to Dave and let him show you some cool things that we're doing, because I showed you the bouncing ball, right? Well, Dave's going to kind of show you what we're doing as it relates to an onboard app and a little Bluetooth radio that now we're talking to the circulator and we're seeing real time what's happening within the system hydraulically. This is cool. So Dave, go ahead. Or John, hand it over to Dave, or whatever we need to do there.
Oh, there we go.
Is it working?
Dave's on mute.
Dave, don't mute yourself.
I am on mute. Yes, damn it.
$20 there, bucko.
Oh man. Oh man, that's only. I was just about to sneeze a loud one before, and I'm like, ugh.
Don't sneeze a loud one.
Hey, before you go, we got a couple of questions here. I want to get to. One was from Joshua Poole. You only want to use the proportional control in a reverse return system where there aren't widely varying sized zones, I guess is the question. So I'd say reverse return or direct return, as Rick pointed out, or that thermostat in a smaller sense, that thermostatic radiator valve, continuous circulation type of an application. think those would be the ones. Rick, is that kind of concur with what you were saying?
Yeah. Again, it wouldn't matter if it was a two-pipe direct return or a two-pipe reverse return.
Mhm.
The circulator doesn't know how you piped it, right? The circulator is oblivious to that. So what we do want it to, what it'll feel is a drop in pressure that's based on the pressure that's in the extended header. And as the zone valves close, that's reduced. Therefore, we can drop the pitch. Okay, so it would apply to both. That would be a simpler, quicker answer.
John Freeland asked, what pumps can do delta T? For us, it's the VT2218. 22, the maximum speed pitch goes from 22 feet ahead out to 18 gallons per minute. And then it goes to a minimum speed of about 4 feet ahead out to 7 gallons a minute. And that may be, I'm glad you brought that up, John. That might be as close as we have to an automatic sizing circulator that there is in the industry. It's based on trying to maintain a fixed delta T within the system. So let's say we set this up for a 20-degree delta T. You'll have a sensor on the supply going out and a sensor on the return coming back. And it's just monitoring the temperature difference between what's going out to the system and what's coming back from the system. And it'll adjust its speed to maintain whatever temperature you have as best it can. Once it hits minimum speed, it's not a delta T pump anymore. It's a 9-watt fixed speed pump, right? And that's all you got. So it's good on good size systems. It'll vary its speed as zones open and close. It'll also vary its speed with the weather, believe it or not, because you're taking fewer BTUs out of the system. Someone had asked earlier, which is better, constant pressure or delta T? And my feeling is in virtually every instance, delta T is a superior way to run a system, as long as you fit within that slot. Now, in some cases, the bigger the system, the more of that wedge you're actually going to use for variable speededness. So in some cases, the difference is this big. I mean, it's a big difference between the two. In some cases, the difference is much narrower in terms of operation between the two. And in some cases, the difference is non-existent. Okay. And then the advantages might not be worth the added cost of the pressure of the circulator. So so there's that to think about. Large single zones, it's a very good circulator. Large zone valve applications, it's a very good circulator to use.
I've successfully used it as a boiler circulator as well. Remember, a delta P pump won't know what to do, speeding up or slowing down. I had a mod con in my house. I just sold the house, but it's on its 6th season right now, working very successfully as a delta T pump across the boiler's heat exchanger. And it's doing nothing more than what the boiler manufacturers are already doing, but it's doing it standalone with TACO technology rather than the internal boiler technology, and it's worked well flawlessly. Again, it's on a 6th season. I've had no issues whatsoever.
And Michael Jablonski asked a really good question. Why not use the 2218 on the examples that you showed instead of the constant pressure? I would go so far as to say you could use a delta T pump as long as it's big enough in any of the examples that Rick used.
Yeah,
except for the 75 gallons at whatever feet ahead, it's not big enough. But any of the more common residential applications, substitute the delta T pump for any of those, any operating mode, constant pressure, proportional pressure, or fixed speed, and you'll have a better performing pump.
We have drawings on all that too. If you want to see those same examples that I showed you with the delta P pumps with delta T, I've got some of those as well. So, send us a request and we've got a nice little thing that we can send you. It's nothing that's published by TACO, but it's something that we use within our training department. So.
And Richard McGrath liked variable speededness.
Of course.
All right. Very good. Sorry, Dave, take it away, buddy.
Oh, no problem at all. No problem at all. Hey, and thanks for everybody that is, so to speak, conversing with us. That is very, very useful for us. And for those of you that may or may not know, that's how I go through the pile of stuff that I have in my garage, okay, and giving things away. So that's what I end up doing. Let me take hang on a second. Show my screen. Wrong screen, probably. All right.
There you go.
There we go. So
Wieners.
I do a random, based upon the interaction from people, and I can get the information out of the software. So these are the winners from last week, by the way. All right. If you see your name there, I emailed you, but you may not have gotten it, or maybe it got stuck on a spam filter or something like that. Please contact me. My email, davhol@takocomfort.com. And I'll make sure I send out a t-shirt. The t-shirts that Rick and John are wearing, I got a pile of them. I don't want to keep a pile of them. So I want to give some of those away. So email me back, and I'll make sure I get one of those sent to you, and at least a mask. And then other times I do is I will send out. I do pick a grand prize of more than just the T-shirt and the mask. So I just want to make sure that everybody knows that you're answering questions, you're asking questions. Thank you, thank you, thank you. That's what we use to select some of the winners out there. And then if I don't have enough of those, then I'm just going to go random names too at the same time. So again, anybody that attends, greatly, greatly appreciate it. So with that being said, let me go back and share a different screen. There we go.
Yep.
All right, so you can see my iPad. All right, so what I did is I have my iPad linked to my laptop here. And
looking good.
I'm gonna move the camera, so hang on with me so you guys get a better view of what I'm playing around with and messing with over here. So I have this display panel in the back here. So I've got a 0018 Circulator on here. Let me get the microphone sent out and not crash the office. All right, so then we've got our resident Rick. Let me move him out of the way here. 18E, got a couple of zone valves on here. The circulator has been running. My zones are open. So with this circulator that has the Bluetooth communication in here, you're not pairing to it like you would a circulator, like your headset or anything. All right, Emma says she doesn't see it. I just happen to see that pop up. I just want to make sure. I know Rick and John see it. Want to make sure everybody else does see the iPad app. If you're using a device, might be a little different. You might have to swipe to the left or the right if they're seeing us. So, but I don't have the, I didn't open up the app just yet. So you don't have to pair to it. It is just a handshake. It's just a part-time communication that's going to happen to it. So the first thing I'm going to do, one, you got to make sure the circulator is powered up and running. Okay. Two, I'm going to come along and I'm going to hit the ECM 0018 app that I have on my program. Okay. So, I mean, on my iPad. So just tap on that. And the first thing that you're going to see, it says 0018E. And there is a pop-up that is going to look for all of the 0018E circulators that are running at the moment. So you'll see the first one listed, it says demo. All right, that is if you don't have an app. I mean, you don't have a circulator, but you want to learn how to use the app. Okay, use the demo. First floor is the name of this circulator. So I've named this one first floor. The 0018E that you see on the bottom there, that's actually the one that is in my house and my domestic hot water indirect tank. So it's actually, I guess it's running at the moment. Somebody must be in taking the shower. It is that time, yes. A couple of teenagers in the home that had sports after school today. So what I'm going to do is I'm going to tap on first floor. And you see the light flashing on the circulator here, which means it is shaking hands. My iPad is now talking to that circulator. Okay, so as soon as the light flashes, now we get to see in the Bluetooth communication mode what mode it was running in. And where I last used this was in the zone circ mode and is running at about 40% speed. So what you see is the blue field is the minimum and the maximum of the circulator, and it can run anywhere in there based upon the system curve
Yeah.
that is being developed over here, and the speed of the circulator. So the blue dot that you see is the actual performance of the circulator itself. That is what it's operating at. And if you're not sure what that is, if you look over here, it's going to give you the actual gallons per minute and the foot ahead that it's operating at. So 5.5
Very good.
gallons a minute at 5.5 foot ahead. It does tell you the
5.5.
wattage and the RPM of the circulator. This circulator runs up to about 4,400 RPM, but right now it's only running at about 2,800. Sounds good?
I love it.
Excellent. All right, so David asks, does every pump come with its own unique ID? They are all named the same, 0018E. You get the options to change it yourself. You do have the 3 ellipses up here at the top of the screen. You can click on that and you'll get a menu. Now, a couple other things that I want you to see right away that we see here on the screen itself is the number of working hours this circulator has run. So it's run for 105 hours since the day I put it into this system. It's been started and stopped 57 times. So I've done 57 webinars or seminars with this circulator. It has consumed a total of 1.78 kilowatt hours. So I need to submit that, John, to my expense report for next month. All right.
Good luck. Yeah, there we go.
At 22 cents a kilowatt here on Long Island, that's a lot, you know. So, and the alarms are the sure starts that we've talked about before. This one hasn't gone into that mode at all, whether it's been sure start kicking on and off from air or dirt that's going on. Now, what you'll also notice is that this circulator is kind of grayed out all the features to change the applications or change the mode of the circulator. This is right now in homeowner mode, which means all I have is read capabilities. I do not have read-write capabilities. So a lot of people get concerned that you install this Bluetooth circulator in the house and now a homeowner is going to mess with it. You know, download the app and mess around with it. He sure can. Actually, all he can do is take a look at it. Because if I go and tap on zone valve, a window is going to pop up and said this circulator is in read-only mode and apps are disabled. The only way to reactivate two-way communication is to rotate the dial and then back to the Bluetooth setting. That means the homeowner is going to have to go downstairs and physically touch it. All right, so if they're not doing that, or maybe they don't want to go and touch it, they're not sure. Maybe they were just messing around with it at first, you know, want to see what it can do. So I have to take my screwdriver out, come up to the circulator, take the dial, and then put it right back again. And now you see that
He's spinning
everything.
that up and back, up and back.
Yes.
Yeah.
All I did is take it out of the Bluetooth mode is just this little small quadrant of the dial.
Yep.
All right, so then it's done. And now it's back in there. And now you can see everything nice and bright. And now we're in read-write mode where I can go ahead and change it as much as I want to. So I can go ahead and change the speed of this circulator. So I can take that dot that's sitting right there, put my finger on it, and slide it to what speed I want to set it for. And you're going to see the working dot change. Follow the system curve. It's still following the curve going up. All right. And now we're running at 72% speed, 7.8 gallons a minute at 9.8 foot ahead, 37 watts. And now we're at 3,900 RPM. As you can tell, we're really close to the max RPM of the circulator there. Okay. So very, very, very useful app in what you can do into dialing it. You know, we talked about doing the math, all right, up until this point, and we always talk about doing the math. Now you can verify that your circulator is doing what you wanted it to do. That's what I feel is also the best part about it. We spend all this time doing the math, we turn the system on and guess, and we hope and pray that it's going to do what we wanted it to do. All right, if the phone doesn't ring, then it's a good day. When the phone rings, oh crap, now we got to go back and fix it and figure out what's going on. Now, at least before you leave the job site, you know where you left it.
Hey, Dave.
Yes, sir.
Let me, before you start pushing additional buttons, point at the zone valve icon and the TRV icon. So
All right,
you guys,
you can see my mouse, right?
yeah, we just
Okay.
spent a bunch of time talking to you about those. Now, from a generic terminology, what would the zone valve mode be?
You asking me or you're asking everybody
No,
else?
I'm asking them to type something in there. Just
Oh,
getting.
okay, gotcha. Just making sure. Exactly, Chris. Yes. Zone valve mode. Yep. Josh has got it.
Very good. I know you're going to play with that, but notice that we took the generic names away and we put names on there. So we want to make sure everybody gets that.
Yep. So we try to use that interchangeably, whether it's going, and then for those of you that are not sure, zone valve, constant pressure mode, right? Constant discharge pressure, maintaining that flat pump curve going across. So that's our zone valve mode that we see here on the circulator. TRV, proportional pressure, and that's what also the little icons are.
Yep.
All right. You see the head and flow, and then you see the straight line across being constant pressure, proportional pressure, and then active adapt. So I'm going to tap on zone valve.
Very good.
And right now, this is in the zone valve mode. You see it turned orange. The light also changed orange on the circulator. It was blue before.
Mhm.
All right. And now we're operating at 10 foot ahead. All right. And at 8.3 gallons a minute. So if you notice that the operating point is almost in the exact same point. That's just by chance. Now, if you want to change what curve it's supposed to operate on, now we have 9 different curves. I can just tap on the screen and tap on the line itself close to it, and it's going to operate down on that curve. Or I can hit the arrows on either side here of which curve it's going to operate at. And now, as you can see, it's hunting to bring it down to now around 8 foot ahead, 7.5 foot ahead or so. And now it's going to finalize and get to that point that you're looking for. All right, so let me get it back to our 10 foot ahead. And you'll see also the wattage is going to change, the RPMs are going to change. And let's go ahead and close off a zone. So I go and close the zone valve off, so that zone's now closing, and you're going to see this, the dot is going to start working to the left. All right, it's less gallons per minute. It obviously has to. Right, so as it starts to settle out, find where it needs to be at, get its fine tune of speed and wattage. Let's go ahead and close down a second one and watch this thing come on back. So you see that little dip up that Rick was talking about earlier, the dip up, and then it comes back down to its curve. And obviously, as the further you go down on the curves, then you can see how much more speediness you got. I had to use it. Had to use it.
I like it. Speediness.
Speededness, variable speededness.
Speededness, yes. And now we click on TRV mode, and here's your TRV. And again, 9 different curves to choose from. If you know which curve you want it to operate on, there you go. You choose the one that you want it to run at. So I'm going to bring it all the way down to the low speed. And I can just hear this thing quieting down on me just because these little flow meters are getting a little beat up on my system here. Running 2.6 gallons a minute, just about 5 foot ahead. And then we come over to active adapt, and the active adapt, because I haven't had it run at all really in this speed, it always operates on the second from the top curve, and then we'll learn about an hour and a half to 2 hours, and then it's going to say, all right, whether it needs to speed up or slow down. So it's going to start here, but I got to have it run continuously for an hour, at least an hour and a half, to figure out where it wants to run at as your thermostatic radiator valves and proportional pressure style system starts to open and close throughout the project. All right, that's what we're looking there for. All right, now I saw a couple of questions come in before. One of them from Terry: can you download or save historical data from the pump to the app? All right, yeah, man. All right, so there is some data that's stored on the circulator, but
What I tell you, Terry? What I tell you?
But there are some there's data that's stored on here, but reports, you can create reports. The reports are saved on your device, not necessarily on the circuit itself. So let's go to the ellipses up at the top in here, and I'll show you a couple of the things that we have up there. So as that pulls open, you see I can change the circulator. So if you had multiple 18Es in here, you can go ahead and change to them. My suggestion if you have more than one on a project, only for the first time, only turn one on at a time.
Yeah.
You can't tell it which one to go to. All right, because they're all going to pop up as 18E. So you turn on 5 circulators the first time, you're going to see all 5 of them listed, and you're not going to know which one is which. So turn one on and then communicate to it. Change the name if you wanted to, to name them first floor, second floor, third floor, or you want to name them 1, 2, 3, 4 because it was from left to right, or as John always says, if you want to name them Mo, Larry, and Curly, it's your right. You can name them whatever you'd like. So that happens under the settings section that you see here. General information is going to get you to the instruction sheet, get to the website, all these different things. Here it is, the reporting. All right, you've got report data, you've got new report or all reports. So I go ahead and click on all reports for a second, and I'm going to show you all the reports that I have done with this iPad. Not necessarily just that circulator itself, but with different ones that I have out there. So I created one back in November, it says here. It was the last time I created a report. If I click on that, it's going to pull in. And here's all the pertinent data from that day. All right, at 3 o'clock in the afternoon, you put in your company information in here. The installation address of the circulator is actually going to be saved. All right, and it's actually, if you look right below that, it says GPS. It's using the GPS of your device, not the circulator, just your device when you created the circulator, when you set up that circulator. You've got an installer name, and as you start scrolling down, there is an individual ID of every circulator. So this is already built in. You can't change that. That's part of the circulator. But the beauty of this too is that you get to take a picture of the circulator and or the application or the job site if you wanted to, and it is stored with it. Obviously, I took a picture of my board that I have here. And as we start scrolling down, you'll see 73 hours. You know, it's up to 105 now. All right, it was up, and it has 43 shutdowns. The total power load there, what mode it was left at, which is important. Let's say somebody did, go down to the circulator, turned it with the screwdriver, got back into it, changed the settings, called you up and said, it's not working now, and I didn't touch it. At least if you created this commissioning report when you left it, what mode it was left in, you say, well, this is the mode it's supposed to be in, and it's not when I got here, somebody touched it. All right, so so that's something good to know. And you'll see the flow and head on the right-hand side, the speed and the power consumption, and then you'll also see the curve on where you left it, and you can also email that out to yourself, to the customer, wherever you want to.
Cool stuff.
And we recommend doing a report every time you visit the job. That way you have a report for every visit, and you can see what's happening. You can see, well, this was the power consumption last time. This is the cumulative power consumption this time. Some quick math will tell you, the difference between the two. So you can see how many watts it's consumed in that over the past year. You can also it also tells you the amount of run hours and the number of cycles, which can be really useful in determining, well, maybe did I in fact set this thing up optimally, or am I oversized? So if you have a lot of run, if you have a certain amount of run hours, but you got a ton of cycles, maybe I oversized that. I picked the wrong curve. Maybe I can dial it down and have fewer cycles in the same amount of runtime.
Exactly right. And what's nice here, this alarm is telling you if you went into sure start at all.
Oh, there you go. Yeah.
All right. If it went into air purging, you click on the alarms, it's going to tell you if it's gone into air purging. That means, hey, I need to take a look at my air elimination that I have set up in the system. Do I have it set up properly? Is it failed? Am I seeing more air in my system, which means, do I have a leak somewhere in the house? And I may not know it because my fill valve is automatically filling it back in. And then it goes into sure start, as in the seized rotor application. And you might need to consider some dirt separation, some chemical means, whatever you do to clean up the water quality that you have in there. You might have to put in a magnetic dirt separator. You may need to put in some chemicals in order to clean the system. So if you happen to see those alarms go often, that's what you should look for.
Hey, Dave,
Yes, sir.
can I have you walk through something if I give you some? I want to show them, and in fact, I'll wait till you're done because I want to show them more of that midnight on New Year's Eve kind of scenario.
All right, go ahead. Tell me what you want to do.
Why don't you do midnight on February 3rd?
Okay.
Why does it have to be New Year's Eve or Christmas Eve? Give the other days of the year some love, man.
Ask these contractors
I
when
don't
things
think
go wrong. They've already been drinking and they're out working. Just teasing. Cool. Thanksgiving night. Very good, Mario.
There you go. I like Thanksgiving night.
Yeah.
All right. So what are you thinking there, Rick? What's your scenario here? What are you talking about?
So we're standing. We just in front of the boiler. We just purged it. We replaced it. It's been running on high like it's supposed to burp the wet rotor circulators. Now we want to get it set up, but we're unsure. We haven't done any calculations, but we want to get an idea of what the resistance of the system is. Remember, John and Dave and I have showed you over and over again, if you sat through any of our classes, how to estimate what the pressure drop is of a system based on total developed length and elbows and all this stuff that we have to kind of look at as far as the calculation is concerned. We never know for sure until what? Until we put the circulator in, and now this gives us the beauty of telling how close we got in our estimation. But again, at midnight on February 23rd, is that what it was?
Close enough.
Close enough. February something.
Tonight.
We're into March already. Let's call it March 3rd. Anyway, so when we're there, let's do something that's kind of cool, and this will establish for you what the hydraulic resistance of that particular system is. Okay.
Okay. Oh, okay. Yeah. So you got a zone valve system here.
Yeah. So open up all the zone valves. I'm going to try to walk them through what they want to do in the mechanical room.
Yep.
Open up all the zone valves and turn the circulator on zone circ or fixed speed. Okay. And turn it all the way up to 100%. And it takes a little bit. This is the hydraulic equilibrium, as a big word. Everything's going to mellow out in just maybe a few seconds. Maybe let's give it 15, 20 seconds, and it'll kind of settle in on what the resistance of that particular system you just put the pump in is. And you can go, okay, well, that's with everything open and the pump running at maximum, and you get an idea. Do you really need 9 gallons a minute? Notice it's at 9 gallons a minute at 10 foot ahead. Now you can kind of quickly say, okay, this boiler is X amount of size. You see where I'm going with this. This will give you some good numbers to make a decision. Now let's say that it is a zone valve job. You've got zone valves piped in, parallel supplies and returns that come all the way home. Okay, so we want to, we know that the worst case scenario is showing up for us right there. So here's a suggestion. I would go slightly under that. You can see that you're at about 9.5, 10 feet of head. So if I wanted zone valve application or constant pressure, now touch the zone valve icon, Dave.
What's that? Zone valve?
The zone valve icon and see where it's right. It kind of splits the difference at 9 and 10 and a little bit below. Here's my suggestion to do. Go to that one that's a little bit below and start once it settles out. Remember, it takes a few seconds to reach equilibrium. And then you manually have all the zone valves open. Now you start closing them one at a time and watch what the unit does for you. This is not settling right on that bold line, but you'll get the point of what it does. See how he closed the valve and now it starts slowing down? Okay, and then you kind of look at the job. Remember, you haven't done any math, you've never been to the job before, but you replace the circulator and you want to get it set up in the right mode and the right setting within the mode. And this is one way of doing that. Okay, other people have gone through and said, I'm gonna put it right on the GPM I want. Well, there's only one way to know what the GPM is, and if you have a good idea what the BTUs are. So anyway, I'm just showing you another way to do the midnight run. So
That's right.
thanks, Dave.
No problem. Yes, that's it. Yeah, you don't know the head loss. You have an idea of gallons per minute, maybe taking a look at how much baseboard or what you're connected to find your GPM, but you have no idea the head loss. It's a quick way to figure out which one of these 9 curves to set the circulator up for.
Yeah,
All right?
Terry's saying,
Time.
he's saying you could plot the system curve at this point, and that's absolutely right. A lot of people don't know how to plot the system curve. They don't know that math, but we could sure teach you.
Excellent. All righty. I see the questions coming in pretty good, and John's typing away like mad. Excellent. Glad to hear it.
I gotta let the keyboards cool off.
And
A
Rick,
couple of them was
I realized
really-
it was me with the noise on the clacking away on the keyboard earlier because I was using the wrong microphone.
Yeah.
I muted you on this end, so
I saw
have
that.
the
Yes.
ability.
Oh.
A couple of good questions came out, both from Omer about any connectivity issues. Are there concerns about this being, new technology? Well, first, Bluetooth's been around a long time.
Long time.
It's pretty reliable connectivity. We don't connect, the pump doesn't connect to Wi-Fi at all. All right, it's not a Wi-Fi connectivity. We don't connect to the home's router or anything. It's just the phone to the pump.
Between you and the phone. The pump.
Yeah,
and the phone.
it's like connecting a set of speakers or a pair of headphones. It's the same thing. And then on top of that, it only has to be connected. It only has to be connected while you're setting it up or while you're doing a little service check. It doesn't need to be connected to anything to operate. All right. So once you leave, that circulator is not connected to anything. All right. It's just running like a normal circulator would. So
And my connectivity issues that I've run into every once in a while, all of a sudden, when you're sitting here playing around and doing, and I see it mostly on my end because I do the training classes and I'm going through all the different screens. Every once in a while, it may drop out, where I have to go back and hit change pump. And sometimes you'll just see the little circle in the middle say, all right, reconnecting, and it connects back up again relatively quickly. So that's about it that I've run into in communication or issues with the circulator. We've had the 18E out circulator now for just over 2 years, I believe. So, and the only thing that's different, say compared to, a 7E or a 15E, is that it has a Bluetooth chip on the same circuit board that's on the inside there. That's it. All we did is run power to it and then actually write that software that you see here on the screen itself and write the app. So it is a very seamless transition in order to get the Bluetooth out of there.
Todd Raymond asks, do you need to take the pump out of Bluetooth mode when you're done, or can you just leave it there?
Leave it there.
Leave it there.
Yeah, because if you go and if, let's say you don't have the app downloaded or you don't have your phone on you or anything like that whatsoever, and you have an 18 installed on a project and you don't know what to do with it and you don't have an app to do, all right, just go ahead and set it for whatever setting you want it to. So we have that option, so you can set this up without an app. You just got the dial, and if you really don't know, all right, turn it all the way to the right. All right, you turn it to the right.
Contractor, no callback mode, baby.
Done.
Yeah.
It's giving you everything it's got, baby.
Yeah. Well, unless it's a domestic hot water system, don't do that.
No,
Yeah,
right.
You don't need the app in order to make the circulator work. Obviously, it makes life easier if you do, but you can make it work just fine.
Hey, Dave.
Minus the app.
Can
Yes,
I plug, well, next week a little bit, I'll plug, as well as I want to mention what we'll be able to do. Folks, next week we've got a session similar to this where we're going to actually go through and talk about domestic hot water essentials. So if you folks that are doing domestic hot water recirculation, we're going to dive into the kind of the same thing we did on this session, particular to domestic hot water. But with that said, I showed you a quick picture of a 0018E stainless steel. Now, so look at what Dave just showed you. Dave, we can always see what two things?
Go
GPM
ahead.
and feed ahead. Now, as far as the proportional pressure, constant pressure, active adapt, you typically will never need that in domestic hot water recirculation. Right. We want that fixed speed mode. In this case, we call it zone circ. You'll go to that mode, but what you'll be able to do is we'll have a quick lookup, and you'll see this next week. We'll have the ability to look up what is the maximum flow in gallons per minute for that particular type and size of pipe that's used as the dedicated return of that recirc system. Now we can protect the system from not over pumping. And guess what? We have 100 speeds to get it figured out. Nobody else can do that. So
and if you go by if you go by like 1/10 of a watt, we have over 4,400 speeds.
I love
if you think
but
about
in this case, the reason I say 100 here and not 44 is because it's 100% down to 1%. We have
I'm going, if you go by 1/10 of a watt.
Okay.
Actually, yeah, and this actually, you see, we're 13.92. We actually go out to the 100th of a watt. So we actually have 44,000 different possibilities for you to set this pump up. If that's not enough speeds for you, we can't help you.
Yeah. Well, we invite you all back next week. Those who get to do the design and the commissioning and configuration and service of domestic hot water recirc system, folks, hopefully it'll be an eye-opener, and there's a lot to be said in the world of domestic hot water. So again, TACO's a heating company, but boy, we're all about pumps, and there's one used in almost every house as it relates to domestic hot water.
There you go. Hey, now what about if Mrs. Jones's husband decides to, or Mr. Jones's wife decides to download the app themselves and play around with this pump? Is there anything to prevent them from doing that?
Not at all.
Nope.
It's theirs. They can
it's
do
their
what they
pump.
want.
They own it. It's their pump. They can do whatever the heck they want with it. Yeah. It's just a matter of, just think of what's going to have to happen. First off, they're going to have to know there's a Bluetooth connection to it, and if you don't tell them, they're never going to know. They're going to have to know the name of the app. They're going to have to go find the app. They're going to have to download the app, and they're going to have to figure out how to connect it to what they have, and then start playing with it. Now, that said, can it happen? Well, sure. But that's why you do a report every time you leave that job. Before you leave, you do a report, you save the report, you send it to yourself, so you have it on file. It's always saved on your device. So if you get there, and as David said earlier, if this thing is all messed up, okay, if it's not the way you left it, all right, what happened? Because this is how I left it. This is the last time I was here. This is the report from the last time. What happened? Well, we decided to see if we could make it better. It says, well, you didn't, did you? All right, you didn't. Yeah, and that's it. As Dave Cullen says, transparency is a good thing. Good tech should do the report and share it with the homeowner. Absolutely. Yeah. With being Bluetooth, will it show up on a router? No, because it's not. Again, it's not
Wi-Fi.
Wi-Fi. It's not Wi-Fi. Just like, I got a set of headphones here. All right. I got a set of Bluetooth headphones. This doesn't show up on the router. It's just going to show up on this when I turn the Bluetooth on.
Yep.
And I connect them if I want. All right.
John, you got a question there from Omer about buffers and storage tanks, and of course we do. Yeah, we
commercially.
We sell storage tanks and buffer tanks for big commercial applications. The smaller residential applications, we do not, because there are a lot of companies out there that do them and do them very well. Yeah. We do offer a program on how to size them, and maybe that's something we will do on our. Maybe that's a good tip and trick for the March 17th finale. Write that down, Dave.
That's Dave's.
Why can't I win? Why can't I win?
Because the fine print at the bottom, employees of the company. Now I have to give. I can't
No,
keep
no,
any-
no, 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 no. Who makes the rules for this department? No, 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 no. I can win. If the group says my tip and trick is the best, I can win, right? You guys, are you with me?
Yeah.
I have to put
Apparently
it there.
not. All right. Well, I've been thrown under the bus before, people. Okay. All right. But yeah, well, that's a good one. I'm glad you asked that. We will do that, Omar, on the 17th. We'll go through how to size a buffer tank for a residential application. I love it. Good, 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 good. That's one of my favorites.
Okay, so I just so now things just happened on my iPad. So if you just noticed, I got an error, not communicating to it. So, and that's just because I'm turning things off on my computer and whatnot, so that can happen. So all you do is just hit reconnect, and it just researches for it again, and it'll find it. So that's the only connectivity issues I've ever run into. And now I'm back talking to it. So all good. Excellent.
All right,
All right, so how many of the
send me the jar of peanut butter and the blue cheese and the blue
Hey, you know
cheese.
what? Nowadays you can get a tube of peanut butter.
Ew.
Yeah.
I bought a tube of tomato paste, double concentrated tomato paste.
Yeah.
Yes. We already got it to food. We didn't even go through anything yet, man.
I know,
So,
I know. It's just, well, I love to cook. Made stuffed peppers the other night, vegetarian stuffed peppers. So I'm a vegetarian, people, just so you know that. I'm a year plus into it, and I don't miss meat at all. Actually, I miss hot dogs. I don't miss steaks. I was never a big steak guy. I miss hot dogs because I love hot dogs.
so type in your questions on anything about the presentation tonight, anything at all, or even just hydronic, anything that you want to talk about, please bring them on in. We will stay on as long as you want us to, as long as you guys are and gals are conversing with us, so to speak, then we'll keep on going. If it starts to get a little quiet out there, then all right, we may shut it down. But we do greatly appreciate you all hanging out with us tonight, spending some time. I'm not saying you got to go yet. Hang on, we're not going anywhere. We're still sitting around our home. So please come talk to us.
Absolutely. Yeah, this has been actually once we get past the main presentation, this is usually I love doing the presentations, don't get me wrong, but this part, the interaction that we get to have with you guys is really terrific, especially since we've been in this quarantine travel ban for us. We don't get to present in front of people anymore. Just because we can't. The company has a travel ban, a very strict travel ban in place for our own protection and for the protection of our customers, which makes sense. But that's we miss that. As trainers, we tend to our one marketable skill is the ability to talk nonstop, right? And we're as you can all tell, the three of us are really good at that. But without being able to, yeah, right, there you go. Thank you, Rick. Yeah.
Some more than
without being able to do that, this is really the best medicine for us. And we do appreciate. I mean, we had almost 160 people online in class tonight on a Wednesday night.
I love it.
And that's just so gratifying. Thank you so much for the gift of your time, folks. It really makes us. We appreciate that you are trusting us to deliver you some information.
Clark, I got one here from Travis that he's got a couple. He's firing them off. Thanks, Travis. Stainless steel volutes, let's say the whole portion of the pump, not just the flange, right? So the stainless steel is there for several reasons. The number one is that we need that a product that's NSF 61 certified, National Sanitation Foundation or whatever. We got to make sure that we're not going to impart anything into the fluid so that we're not, poisoning anybody or not rusting and that sort of thing. So NSF is really strict at making sure that we have product that's low lead or no lead, something like that. But there's plenty of places, like I'm out west, right? And there's plenty of different things that go in California and nowhere else, right? There's California, a lot of the engineers out there, they just specify stainless steel on closed loop systems as well. They've had issues with people putting in non-barrier, what goes way back to the EPDM rubber tubing, it goes back to polybutylene, goes back to non-barrier PEX. They just said, look, we're just not going to chance it. We don't know what's in the ground. We're just going to specify everything with stainless steel, and TACO was missing out on a lot of that. So it's not just domestic water applications or domestic water recirculation, but it's other things where you might want to never have a corrosion situation within the volute of the pump.
Very good, very good. Omer asked another question. Will TACO get into, or something coming down the pipeline of new product that TACO has never offered before? Omer, do you like hang out at our factory? Are you kind of eavesdropping on some of the stuff that we do, that we talk about, man? Because yeah, we've got some pretty cool stuff that you're going to see later on this year. You know, one thing we can tell you about already, and I don't know if it's applicable to anyone in this setting, but something Rick's been working on is commercial booster pumps. I mean, big honking high-rise type booster pump systems for domestic water. We're getting into that. And you're going to see some pretty cool stuff too. We can't really talk about it right now, but it's something that's going to be very outside of our normal offering, but something that's got tremendous possibilities out there. So we're going to be very excited about that. Can't tell you any more though.
Anthony, yes.
Clark took a commercial VFT webinar 13 hours ago. You guys are better. Well, that's all right. Was it we like to think so, but our commercial guys are also very skilled at what they do.
Absolutely.
Was it our guys or somebody else? Hopefully it wasn't ours.
Yeah, was it one of ours or was it somebody else's, Bob? Let me know. I don't
know if we're doing a VFD webinars.
No, I don't think variable frequency drive. Maybe, I don't know. If it was ours, let me know. I'd be surprised. I would be surprised.
We have to go smack them around tomorrow then.
Yeah, Rich and Brett are two of the best, so they really are good.
And they're a good team.
And Bob said not you guys, so good. It was somebody else's. So yeah, thank you. We do try. I'll tell you, we do try to pride ourselves on doing webinars a little bit differently. I mean, whether it's the tag team approach like we have here and like we do on our TACO Tuesdays, but one of the things, we've all worked for a living too, all of us, so we can speak the language and we know what you guys deal with every day. So hopefully that you know, it comes through, and we really like this too. I mean, we're pretty good communicators, and we enjoy it. We enjoy doing this, and we appreciate you guys having. We appreciate you guys being with us, because if there was nobody here, we'd be talking to ourselves, and we feel kind of silly. Yeah. Not that we wouldn't talk, we'd still talk.
We still do this anyway. Yeah, sometimes.
NSF questions. We meet all the requirements for domestic hot water, potable water, warm water applications. We even have some product that actually meets NSF hot listing, which is up to 180 degrees. Now, depending on what product it is, some are just normal temperature and some are all the way up to 180. But Anthony's asking, and I think hopefully that NSF 61 and 372, 373, we meet the criteria needed to put our product in those applications. So good thing is, on the documentation itself, we have the sticker, the listing, and we can supply that information to back it up.
Here's another question from Omer. How do I convince my teenage son that TACO After Dark is about pumps? He believes it's about tacos and food obsession. Well, here's what you do. We've used this for forever, and it applies. TACO is for heating, tacos are for eating. Or tacos are for eating, TACO is for heating. Either way you word it, it'll get it across. It does work. It'll get the message across. But TACO is for heating, tacos are for eating. At the end of discussion.
Yeah.
All right. Let's see what else. We had a couple. There was another one up here. And Rick, I want to throw this one to you. Where is it? Where is it? Where is it? Where is it? Here we go. Difference between a hydraulic separator and closely spaced tees.
So generally speaking, a hydraulic separator can add the hydraulic separation of the boiler circulator and the system circulator, which is what we can get either way. With a separator, though, you have the ability to add the coalesced media, air separation, dirt mag. You can do all that stuff in one. And there's plenty of people that are making that stuff. Someday we'll have something to offer as well. But closely spaced tees, from the standpoint of separating the boiler circulator from ever affecting the system circulator, does a really good job. And we've done classes on those, and a lot of other people do as well. It's pretty simple math on that. And again, right now, there's a lot of systems that they put hydraulic separators in that don't really need them, meaning that there's a reason to use a hydraulic separator, not just for the sake that it's cool and it's in vogue and it's on all the magazines, right? So right now, Taco's stand on that is we put a very nice 4900 air separator up on the supply, the hottest portion of the system, and we put a magnetic dirt separator down on the return just before it enters the boiler, and that works really good as well. You don't necessarily, in every case, need hydraulic separation.
Yep. Yeah, and yeah, I think you said it very well. It's in all the magazines. All the cool kids use hydraulic separators, right? Whether they need them or not. And in a lot of cases, a hydraulic separator it's really the closely spaced tees thing, but it's built for you. So in a lot of cases, it can be simply a piping convenience item. You know, you either buy it ready-made or you build it yourself. Which way you go, you know? If you got a little bit of mass to them, in some cases, if you have a few zones, then a hydraulic separator might be of benefit, as opposed to building your own header. But that's again one of these. You can accomplish the same thing by oversizing your header, right? Short fat header, man. A short fat header is essentially a hydraulic separator. Double your pipe size on the header, yeah, you got one.
So I saw another question come in here from Bill D'Agostino. He says, with the range of ECM coming out, do you see them taking the place of VFD drives in light commercial?
Maybe.
Well, we already do see that. Yes, they are
Yeah.
ECM motors for the energy efficiency side of things. So last year in January, Circulator design 1 horse and above had to reach certain energy standards. And how they do the calculations between the hydraulic portion of the circulator and the power draw that it has. So there are ECM motors that are getting dropped straight in there. Not necessarily do they have a VFD on there. The VFD is also used to help find the flow better compared to, say, the software that we have here. But that direction is going to obviously change as time goes on, I'm sure. Because you can't necessarily put a VFD on an ECM circulator, I think. Not yet anyway, right, Rick? Do you know?
Say it again. I was reading one of the questions. I'm sorry.
Can you put a VFD on an ECM motor? I don't think you can.
Yeah, no, that's the optimized offering. When you read what we're doing in, the OE offering from Taco is the combination of those two things. We've got a variable frequency drive, and I think it's up to around 20 horsepower, 30 horsepower. We can get an ECM motor. So the I shouldn't say ECM motor, the EC motor up to 20, 30 horsepower, and the variable frequency drive working in conjunction is the optimized efficiencies, hence the OE. So
here's a good question from Carrie Gregg. Can you go back to your graphic on the closely spaced tees and show why you X'd out the need for the circulator? I think Carrie, what you're getting at is he didn't X out the need for the circulator. He X'd out the particular operating mode for that circulator. I think it wasn't supposed to be delta P, a constant pressure. It was fixed speed. I think that might be where we're crossing wires here, Carrie. Let me know if that addresses your concern.
Good to clarify that. And again, I don't want to make that impression, and I can see how that might be misinterpreted. But yeah, we're talking about the whole seminar was on modes of operation.
Okay, good. We got it. There we go. Have you guys seen the new Burnham boiler model Alta? It has our pump in it, yay. And it has a lot of promise where you don't have to set combustion or an outdoor sensor. Have you guys seen that one? I haven't seen that one yet.
I have not. I
I
don't know
haven't
anything
been out
about
of
that.
my house. I haven't been out of my house since, over a year. So
That's the purpose of trade shows, man. I can't wait to get back to a trade show and training classes and all this other stuff, man. I mean, I think for the three of us, when we go to trade shows, yes, it's great to see you all out there,
Y'all.
But I know I try to spend some time and I hit the manufacturers to see what they've been working on, and I'll even take the Takeo shirt off just so they don't, talk to me about it, about the Takeo side. I just want to learn about the boilers and whatnot. So one of these days we'll get back to doing trade shows again, definitely.
Right on.
Yeah, we had a question earlier about when do you guys think you'll be out traveling and training again? Nah, I have my doubts on 2021. It's gonna depend on a lot of things. I mean,
CDC.
right now we are kind of through the middle of the year anyway, and we'll see what happens in the second half of the year. And the other thing is we may be willing and able to, but will there be places where we can actually get a group of people together? Would a wholesaler want to have 20 people to come in? That kind of thing. So those are all open questions. So me being me, I'd be surprised if it happens this year. I'd be a little bit surprised, but hey, there's hope, man. There's always hope, and do you want lobster? Need you back in Maine? Hey, I live 10 minutes from Maine right now, so yes. And I can't eat lobster anymore. Okay, that's the other thing I miss. I miss fried clams, I miss lobster, and I miss hot dogs. Okay, those are the three things I miss: fried clams, lobster, and hot dogs.
Yeah, and it's a challenge for me to travel too. Nobody wants to see the New York Long Islander here, traveling around the country. As and not so bad nowadays, but when it was first everything kicking off here, I was ground zero here, for last year. So nobody wanted to. You guys didn't even want to talk to me on camera. They were afraid of it. So.
Well, there's other explanations there, Dave. I mean, come on. Is a hot dog actually meat? Of a kind, I think, Jim, of a kind, yes. I tell you, the best hot dogs I ever had were the brand name Pearl hot dogs. Got them at the Moolah's Market Basket over in Epping. No, in Stratham. Or you can get them in Epping too. But that might be the best hot dog I've ever had in my life. Pearl. Just so you guys know, we share a little bit of everything here. Now, I wouldn't put peanut butter or blue cheese on it, but it's a good hot dog. All right, quick, guys, what do you want on your hot dogs? What do you like on your hot dogs? That would be you too.
Yeah, I throw the kitchen sink at it a lot of times. Sometimes I got to do just the straight, a little bit of mustard, sauerkraut. Hey, I'm a New Yorker, so going to get a dirty water dog is the best way sometimes. Yeah.
There you
Sweet relish, and I love that creamed horseradish.
Oh,
yes.
Ooh, I like it. Bob Clark
and
says.
I actually like the Polish dogs more than the regular hot dog. So.
Okay. Yeah, I'm generally mustard and relish. I stopped putting ketchup on hot dogs when I was 9. That's just after I was 9. No more. No. You put ketchup on a hot dog. Mustard and relish is your go-to. I'll throw some kraut if we got it. I like that. A little bit of kraut. I had back in. Okay, I'm going to start eating meat again. I'm telling you. Yeah, brown mustard, Jim. Very good. Let's see. The coleslaw is actually pretty good. Believe it or not. All right, we got some. Oh, we had a real question here actually.
Yeah, let's go for the real questions.
The real question. There was a real legit question that didn't have anything to do with hot dogs. Where is it? Can you do a program on the pros and cons of zoning with pumps or zone valves? All right.
the best at that.
Oh,
man.
we've got a great program. I think that's going to be part of the spring season. The Takeo After Dark, the spring season, which I think we're going to start sometime in probably early to mid-April, and it'll go. This will be a 10-week program, and it's going to be basically our factory training class done online in 1 hour sessions. So it'll be same format. I mean, we start at 7, we do an hour, and then we yak till everybody says I'm out of here. But that will be that is, I think that's part 4, if I'm not mistaken. I think it's part 4 of the 10-part series, and it's a good one. It's one of our favorites.
And we've also done some Takeo Tuesdays on that,
Yep.
and so you can always go back and take a look at the YouTube page for Takeo Tuesday there. You'll also find back on our website, Flow Pro University may also have that too. So if you get to our website and look at our online training, which is different than this is our webinar series, but you do the online, take a look for the Flow Pro University classes and look for zone valves versus zone pumps.
Yeah, YouTube, we have all of our Takeo Tuesdays, and all are on our own website. We have all of our Takeo Tuesdays and all of the Takeo After Dark archive there, and you'll definitely see. You can find a webinar on that we've done in the past. Absolutely. Good night, Mr. McGrath, wherever you are. Take care of yourself.
We did have another major technical question here. Could you please review the difference between VFD and ECM? They get thrown into the same conversation sometimes.
Yeah.
That comes from Kenya. So anyone?
Yeah, I mean, so a variable frequency drive changes the frequency. You know, we normally here in North America are 60 hertz. So what we do is we change the hertz, we lower the hertz down. The result of lowering the hertz results is a lower RPM of the motor speed, which means, you know, we pump less. So that's a way of slowing the circulator down. There's some minimums there too. They typically we don't go below about 20 hertz on the bigger pumps. An ECM.
So basically, so before you finish and move on to the next thing, it's still an AC circulator, alternating current. All right. So your hertz is you know, your sine wave going back and forth, and we're trying to change that curve in order to change the speed of the circulator.
Well, that's on an AC motor, but remember we have ECM now, and that converts to DC, which leads us to the ECM. And the ECM means that it's you know, electronically commutated motor, and that just means that we're bringing the AC voltage into it and we're converting it to DC and controlling it that way. So you could probably say that an ECM does vary the frequency, but again, I don't. I think they're two different things essentially.
Very good. Can you do a real-time video at the factory and show us what goes into building a Takeo pump? You know, that's something we've kicked around. Again, Omar, you're eavesdropping. I know that's because these are things that we talk about all the time. Yeah, we have talked about doing that. One of the challenges we have in doing that is we right now are limiting people who can actually go to the factory. The three of us haven't been to the factory, and I haven't been to the factory in over a year. Yeah. And it's a 2-hour drive, you know, just because there's been no reason, and B, they don't want me there, you know, because they just want to keep people. They're trying to keep the workforce safe and healthy, because if we have a COVID outbreak on the factory floor, we're in serious trouble. So they're very careful about who goes in. But that's something that we have talked about, and this is going to go on much longer. I think we're going to have to look at that.
So yes, when John and I get back to doing factory training classes, yes, more than welcome. And I have a feeling, John, our normal 5 to 6 classes a year, when we come out of this, is probably going to double.
I think you're right. We might have to do more.
A lot of people are going to want to come and travel to Rhode Island, come to, you know, spend our 2 days with us and do our training class live.
Yeah,
rather than
let's
see
hope
these yahoos in the flesh. You know,
that's right. That's
are
right.
they really? What if they look like standing up? I don't know.
Todd Raymond's got his name in there twice for some reason, but hey, Todd, yes, they accomplished the same thing. So again, none of us are electrical engineers, and we couldn't get into the weeds on the ECM and VFD stuff, but we got people that can. So
Here's another good question from Carrie. How does the hot water zone system function in the off season on a combi domestic water heating system? Does it essentially go into hibernation until you have a heat demand?
Yes, it does.
Pretty much,
Definitely. It's the thermostat on the wall that says, hey, I'll turn on or turn off. It's a simple on-off switch. It's the light switch. Your thermostat is it's a switch that looks at air temperature. And if the air temperature says, all right, we're above the heating set point, then it's just going to stay off and not do anything. So the combi boiler, it's not the same water though. All right. So the combi boilers are going to have a heat exchanger for the heat in the house itself, and then you have a separate heat exchanger just for your domestic load. So the two waters don't mix. All right. So you don't have to worry about any of that either.
Very good. Captain Paul's Firehouse Dogs here in Trenton, New Jersey has a devil dog made with a deep fried hot dog, bacon, cheese, coleslaw, and beans. Anthony.
oh man.
I think the allocation is you get to have one of those per lifetime.
Problem is they eat them twice a week.
Oh
or at
my
least
God.
once a week. Yeah.
Limit one per lifetime. Well, did you ever see this must have been on Diners, Drive-ins, and Dives or something, where they had burgers, but the buns were actually grilled cheese sandwiches.
Wow.
I know,
Yeah.
right?
Grilled
Double
cheese sandwich on either side of a burger. Yes.
That's
Yeah.
four pieces of bread on a hamburger.
Yeah, but they double up the burgers, so you got grilled cheese sandwich, burger, grilled cheese sandwich, burger, grilled cheese sandwich.
Wow.
Plus everything else you can throw at it, like the kitchen sink and everything else. It's like, yeah, one per lifetime. That's your allotment. That's what you get.
Yeah. Hey, I'll clarify on Carrie's question on combis. In my background with boilers and stuff, you got two different signals, right? So a domestic hot water call is one thing, right? In those, it's normally a switch that says, hey, I've got X amount of flow going, I need to fire up and do things. And as Dave was alluding to, you got a thermostat for heating that tells it. So maybe that's what you were clarifying, Carrie, is that there's two completely different calls. If you never get a call from heating, it ain't going to do anything. But depending on the style, and this is my point, depending on the style of heat exchanger, some heat exchangers actually combine, they never intermingle, but the heat exchanger has two separate water fluid ways within it. Okay, some have a little brazed plate heat exchanger where the heating water is always the same heating water. Okay, and there's different configurations out there, but know that there's different designs out there, and they will act differently. Like for instance, if the same heat exchanger heats up, it heats both waters up, but if the pump is never brought on and there's no fluid flow through it, it's never going to get hot enough to boil or to flash or anything like that. So it does somewhat hibernate. It just, as long as the pump doesn't come on, that hot water never goes out to the heating system.
I had it in my house in Minnesota. I had an NTI Matrix, which I'm not sure. I don't think they make anymore, but it was they do. Yeah,
Yep.
It was their condensing boiler built into this huge cabinet that had a hot water coil and an air handler built in for hydro air.
Yeah.
And you also had you had tappings up on top to take out additional hydronic heat, and then you had tappings for your domestic hot water. And inside there was a little pump and a diverting valve. And if you had heating, it would divert water to the coil and to your tappings, or it would for domestic hot water call, it would divert the water flow to a brazed plate heat exchanger.
Yeah.
to heat up your domestic hot water. And for that little bitty heat exchanger, we never ran out of hot water. It kept ahead of all of our demands with 4 teenagers growing up plus 2 adults.
Nice.
And that thing was phenomenal. So we had, upstairs we had hydro air through the existing ductwork, and then downstairs we closed off the ductwork, so we didn't have any forced air heat downstairs. We still had it for air conditioning, but we had panel radiators and radiant floor downstairs run off of the water, and it was fantastic. So it and like Rick said, no call for heat. Thing never ran. It was just off.
Yeah.
Some more questions. Will Taco come out with Wi-Fi thermostats that will communicate with its zone panel system that can turn on a wireless zone pump? Yeah, I'm
telling you, man, he's been there. We did mess around with this a couple of years ago. We had a very viable product that we were this kind of close to.
Yeah.
But we weren't manufacturing the thermostat. But we started making these devices, and we were like so almost done, and the thermostat manufacturer that we were getting the device from did not have FCC approval here in the United States,
which is kind of important.
Yeah, so we needed to have the FCC stuff on there, and they just said, no, we're not going to do that. And that was the end of it. And we were like, oh, we basically had to start from scratch over again, and I don't know if we've done anything further with it. So
it's one of those things where if we're going to do that, it's going to have to be something unique and different, because if we just come out with something like RedLink, we've got something like RedLink, and people are going to say, why would I use yours instead of RedLink? Is it better? Is it cheaper? I mean, it's there. We would need to come up with something that's going to be differentiatable on something other than price, and it can't be the same thing. It's got to be something different and unique. We actually have a trade council that we discussed all of this with, and one of the pieces of feedback we got from that particular group, which is not universal, but it was a very interesting piece of feedback that we got, was that I don't need that. What I need is simple, reliable, straightforward, zone control. The enthusiasm for going wireless, even with a whole house system and all that stuff, the enthusiasm for that was not great. And it wasn't the only piece of information we got, the only feedback we got. We got other information as well that said, what, let's make what we have better. If we start getting into some other stuff, let's make sure if we do come out with something, it's not going to be a catch-up product, meaning we're catching up to what's in the industry. It's going to have to be something that's going to be trend-setting.
Yeah, leapfrogged.
Because if it's a Me Too product, if we just come out with something that other people have had for 2 or 3 years, it doesn't do us any good.
No.
And if we have to go in on lower price, well, then we're doing a lot of work for not a lot of money. So it's those are the challenges of being a manufacturer. I mean, there's a lot of cool stuff we could do, but should we? That's the other thing. How does it fit? Terry Turner says there's an excellent book titled Understanding Electronically Commutated Motors, which is part of the RSCS Sustainability Series, written by Christopher Mulhally, who is one of my favorite non-TACO trainers. I'm glad you put that in there, Terry. Thank you. He has a long history with Gentech and Regal Beloit, as well as William Archer, one of the pioneers of ECM technology. Cool. I'll have to look that up. Yeah. Again, ECM's been around since what, 1969? It's not
new
technology. It's been around
it's just new here.
Yeah.
And this newness is what we've been making this ECM version of Circular almost 15, 18 years now.
Well, 21 years is when we came out with it.
Late 1999.
99. Okay, I can't count anymore. So just not here in the States, exactly, in North America. North America, we started doing this about 4, 5, 6 years ago already. But over in Europe, TACO Italia, has been doing it over 20 years already. So
Yeah.
a lot of people think it's new here because you've never seen it yet. And that's also because a 007 ain't broke.
Right.
Right. So sometimes to come along and say, well, what would I need this 007E for? Well, we can only get to so many people in training classes and right now. So that's our goal, is to keep on training, keep on talking about it.
Now, I don't know about where you guys are. We have here in the Northeast, in some of the states, and it's in different parts of the country, there are incentives issued by the utility companies to what they're doing is they're buying efficiency. They're paying you to install an ECM circulator as opposed to a standard efficiency circulator. For the longest time, and I don't know if it's still in effect, for the longest time, you would get buying, let's say, a 007E or a 0015E3, you would get an instant $100 rebate at the counter. So buying Mario says they have the $100 rebate. Yeah, 007E. So you could buy a 007E for less, substantially less than you could buy a 007 for. So that one's an easy decision to make. You buy the 007E because it's $25 or whatever the heck it winds up being. You put that in instead. It's just a less expensive product. So so that's just that drove that business. It continues to drive that business. In other areas where they had temporary rebates, drove that business while the rebate was in place. As soon as the rebate went away, boom, it went right back to the other direction. It's one of those things where it's just driven by the rebates primarily. Now, there are an awful lot of people who put in ECM circulators because they believe in the other advantages that they provide, and those are substantial, right? Those are substantial, but it is a more expensive solution. One of the things, we came up with this earlier about why would you use an ECM as a zone pump when it's not going to vary its speed. It's not going to vary its speed, but it is going to find its happy spot. So it may run at 22 watts instead of 80 or 85 like a standard efficiency circulator. Well, is that going to make a big deal on the customer's electric bill? Not really. It's not a lot of money, but what it does do is it says, you know what? They're going to buy this circulator anyway. It's just a matter of whether you give it to them or not. They're either going to buy it now once and be done with it, or they're going to continue to pay for it with higher electrical costs, but not really getting the benefits. And then the benefits that you get with, like, say, a 0015E3 or that 0018 is the ability to really precisely program that circulator so it's not oversized. So we keep the delta T as wide as we can for as long as we can. And we make sure that system is optimized as much as possible. And that's better for everything. It's better for the life of the system. It's better for the life of the component. It's better for the efficiency of the system, all of that. Plus you get the sure start. Okay, you get for auto unlock in case there's a locked rotor situation. You get the auto, the air purge function. You get all of these other things that add up. You get the ease of wiring and installation with the nut grabbers on the flange, or the wiring box or the wiring plug that you can pull out and do the wiring out here and then put it back. So many other things. There you go. Yeah, it's right there. So many other things that are just way cool. All right, that you don't get. So those are all part of the equation in my estimation that you want to take into account when you're making those decisions. If you have the rebates, well, then it's a no-brainer. If you don't have the rebates, well, then it's a do I install this thing that costs this much versus this thing that costs this much? Well, obviously, what's that extra money getting me? What is it going to do for the value of the system? And think about this, in the overall cost of a system installation, it's bupkis. It's nothing. It doesn't. You're not going to lose a job over the price of 3 or 4 circulators, right? If you are, that's not the reason you lost the job. So there's so many other things to look at and take into account. Does it make your job easier? Does it get the install done faster? Does it improve the performance, life, efficiency of the system? Those are all things to take into account. And yeah, Mario pointed that they have the $100 rebate for the circulators, but there's no rebate for zone valves. And if you think about it, that's silly, because why are they incentivizing high efficiency circulators? To save electricity, to lessen the load on the power grid.
Right.
Okay, they're buying efficiency to lessen the load on the power grid. Well, what lessens the load on the power grid more? 5 007Es or 1 007E and 5 zone sentry zone valves?
Yeah.
It's hard to quantify that. That's the thing. It's very, very hard to quantify zone valves. Pumps, yeah, you buy a pump, you get this. You buy this, you get this. That's easy. All right. So I understand why it was done that way, but it's one of those head scratchers.
Oh, of course. And I've spoken to guys about it, and they said, all right, so I can buy a circulator now for less than a zone valve, so I'm going to do zone pumps in this house rather than zone valves. Whereas before there used to be a zone valve type of installer, one pump, multiple zone valves, and then all of a sudden they said, oh, well, these circs are now less expensive than a zone valve. I'm going to put zone pumps in now instead. So I understand that side of it. And he says, when the rebate goes away, then I'll switch back.
Yep.
So got a question here from Kevin. What's up, brother? About taking the circulators apart. All right, any of the ECM circulators that we have here, when you want to take this apart. For example, when your installation and your flow direction is going down like this, and you take it out of the box and the label's upside down. Now, for maybe 50% of you, this is fine. The other 50% of you, it would drive you absolutely crazy that this is upside down, and you would want to rotate that. It all depends if your boiler room has a door on it or not.
Or
It's
your
got a
level
door.
of OCD. My level of OCD is not great, but that would drive me nuts.
Yeah.
I turn the light off and close the door and you don't see it. So, but, and that's how and it's my house, right? Who's looking at my boiler room? Not my family, just me. But anyways, if you wanted to take this apart in order to get the circulator to face upwards here, there are 4 Allen screws here in the corners. Take each one of those 4 bolts out. Now, what you will notice compared to taking a standard 00 apart is that this motor will stay in place. It will not fall and hit the deck. All right, it is going to stay there. And that is because right here, which mine doesn't have, but this one that I have taken apart, there is an O-ring right in that groove there, a nice big old fat O-ring that is holding it in. All right, it is a snug fit in there. So what I don't want you to do is to take this apart and try to push it back together, because most of the time when you go to rotate the motor, you already have it installed. So just because it's acting like a separate set of hands for you. So when you take those 4 bolts out, grab the motor and just twist it to whatever quadrant you want it to go in. All right, don't take it apart, because I'm not saying you can't put it back together, but it's much harder, and the instance of kinking that O-ring or chafing the O-ring goes up.
Yeah.
If you do have it apart, you're going to have it on your bench. Put the motor down like that on your workbench, and then wiggle the casing or the volute back into place in order to do that. So make sure you've got that O-ring lubed, and wiggle it back on easily. So I've done that a couple of times, but when it's installed in place with the pipe itself, yeah, you're going to cut that O-ring and you're going to have a leak. So,
and do it before you pressurize the system, because you take those 4 Allens out, that thing will come right out at you at 15 PSI.
No water, do you?
Yeah.
and I suggest
happened.
using a T-handle Allen keys. If you've got some T-handles, I think this one is a 5, if I remember correctly, a 5/16 T-handle. All right. You got the socket ones, they just get it hits in here a little too much. So a T handle works good, or you just got the basic L handle. You just got to be a little more, get the longer ones, something like that. So, but T handles work great. Get yourself a good brand. Don't go to Harbor Freight to buy your Allen keys. They'll strip out on you in no time. So get some good ones. Being an ex-machinist, that's me. I've stripped out many Allen keys. So you get some good ones. Go find the Snap-on guy running around or whatever, and get some good stuff.
What do you put in vegetarian stuffed peppers? Oh, all right. this is the cooking portion of the show again.
And I haven't had dinner yet.
Yeah, I know. Well, it's Takeo after dark here. It's Takeo after lunch for you out there, Rick.
I know.
We used Beyond Beef, which is a pea protein based meat substitute. It doesn't. People say, oh, it tastes just like it doesn't taste just like hamburger. It tastes like what it tastes like, but it's got that it's got a consistency that's familiar. It doesn't taste bad.
It's all about the texture.
It's about the texture and it's what you put in it. So we use that, brown that with some mushrooms. All right, chopped spinach, rice, garlic, a lot of garlic. Being Italian, more garlic the better. A lot of garlic, oregano, basil, you name it. But I clean out the drawer. I clean out the spice drawer. Just put it all in. Cook that up. Oil. One thing I've learned: olive oil on the stuffed peppers, on the peppers themselves, inside and out. Shove it in, top it with a little cheese, bake it till it's crispy, and then you're off to the races, man. It's delish. That's a good stuff.
No botulism with that stuff either, right?
No, not the way I cook it. Does Takeo certified contractor, so a customer knows they are designing and installing correctly. We don't certify, but we will train you. I mean,
Factory trained is the new
factory
word.
trained. Yes, factory trained. Certification is something. Certification is going to imply a relationship that is, it's very different. If you want to be certified, then there's a whole level of stuff that's beyond just sitting through training classes. I mean, you start getting into dealers and things like that, and there's a business relationship there that, it's just for pumps and for what we do, it's just not practical. We went down that route. Remember when all three of us were at Uponor and Wurzbo back in the old days? We went through that thing. Do we certify? Do we train? And certification implies a relationship most contractors don't necessarily want, because now we're in your books, we're in your business, we're in your life, and there's that no, you have very little freedom then. You got to do it this way or you're out. And for something like that, it was worth considering. For a company that makes accessories, it's a little harder. It's a little harder. But we will train you. Oh, we will train you.
You want to take your
we'll
flyers,
give you a certificate.
The certificates that we send to you. You want to hang those on the wall and frame them and go for it.
Yeah.
A lot of guys will put some of them in their presentation books, or if they make a little an iPad based presentation for their customers, they can show all of their certificates as well. Yeah, certificate of attendance, those kinds of things.
Now, with that being said, though, there are certification companies out there like Nate and Nora and several others that are out there that we do have some of our factory classes listed with, or at least being in front of us with. So I haven't explored it. I looked at it quickly in regards to getting some Nate certification with our online classes. And if those of you that are still here, I see we still got about 66 of us hanging out. If Nate certification was important to your webinars that you're learning right now, let me know, because I want to possibly re-explore getting our webinars certified. Every time we do a certification, it's a certain amount of dollars that you need to put into each hour that you do online. So, and I can't just do we have our factory training class already Nate certified, all right, but you would have to do the 16 hours there. When we do the 10 hours online, it's 10 1-hour classes. It's not a 16-hour class.
Right.
So that becomes a challenge there too.
Yeah,
and logistically trying to make that happen over 16 weeks or 10 weeks, as you guys know. I know a lot of you like to come and hang out with us every week, but I know you all haven't made every single week either, all right? Because, hey, life happens, stuff happens. Hey, it gets really cold out and you're doing 16-hour days. So the last thing you wanted to do is just listen to us three, yak on for an hour or so. You're done. You're tired. You probably already missed us. So So, but let me know if you guys are very interested into it. I'll take the survey out of the people here. If you really want NATE certification, I will explore it. I will take a look into it.
Very good. Very good. And yeah, I would imagine over the past year, NATE has probably been looking like, all right, no one's doing these trainings. We're going to need they're going to need to adapt to the new reality as well. So that's that they may be adjusting their business model as well.
Yeah, I think the last time I looked into it was May of last year, so we were still all in the throes of this. So
right, so check that out, because they may have changed things. Yeah, or we can send out a Dave stickers. Yeah, Dave stickers. Others is. See, I'm certified. I like that.
So yes, I did send out a whole bunch of stickers to everybody. So if you actually attended the first session, the first class, I tried to send them out to as many people as I could. Those of you in North America, if you came to first class, I sent them out. So if you're not familiar with those stickers, shoot me an email. So I've got some takeaway after dark stickers here if you're interested, if you guys like those sort of things. And let's see, where's my other one?
Are we gonna plaster them on the Yeti?
I'm gonna give it to them,
yeah,
but I wasn't gonna stick them all over it.
They can put them on. Yeah,
exactly right. Yep.
Joe Finelli's out of wine.
Out of wine.
There you go.
That reminds me.
Hey, well, here's the other thing. Dave, you might be interested in this, is the Takeo After Dark logo, looking at head covers for a driver. The guy got back to me, so we're gonna see what he can put together.
All right.
So if anybody out there's a golfer, like a Takeo After Dark head cover, that might be a prize coming up here. Maybe we'll see.
Can I win it?
If you're not a golfer, it means absolutely nothing to you, right?
Can I win one?
I don't know. Can I win the Yeti? You already shot me down, pal.
You could pull out your checkbook and have one.
Yeah, there you go.
Hey guys, those of you also still online, and we're talking about the big pile of stuff here. And in case you're not sure what this is for, all right, this is for the last class, all right, of the winter essentials. Not the last class ever, but the last winter essentials, the tips and tricks. And if you don't remember,
3 weeks away.
Yep, that class is not done by us. I mean, yeah, I'm going to put a PowerPoint together and a presentation so you can look at it, but the tips and tricks are your tips and tricks. And it doesn't even have to be a tips and trick in the boiler room. It could also be about business. If you're running your own business, it could be anything at all something that you learned, either you learned from somebody or you learned yourself and you said, oh my God, I wish I knew that 10 years ago. Please let me know so I can pass that along to everybody.
Class.
So yeah, let's pay it forward. That's a pay. You know what? We should rename that class and call it Pay It Forward class.
Yeah.
A webinar. So that's what we want to do with that class. And if you submit anything whatsoever, put it on the social media out there and use hashtag #TakeOComfortTips, or email myself, email John, email Rick. Get us that information. I'm gonna send you something regardless. All right, you're gonna get something out of the basement of the stuff of mine. If your tip or whatever you share with us gets to the presentation, because then we're going to go through everything that we get and then create that presentation, then you instantly get Takeo t-shirt. You're going to get a Takeo After Dark shirt. You're going to get a hat and coffee mug. And then you all get to vote on that one that was the best of the night, and that person's going to win this setup. All right, so you guys vote for it. It's not going to be a random spin of the wheel. So I've got this nice big Yeti cooler, job site speaker, little Bluetooth speaker. Oh, Bluetooth speaker. We should have hooked this up tonight.
There you go. Yeah.
The Carhartt bag. You're going to get everything here. If it was not COVID and during the summer, heck, I'd fill that thing and come deliver it. Make sure, and I wouldn't leave until it was emptied.
Right. Does Takeo have any regulations on truck lettering? Not specifically, but obviously use our official logo. which that can be provided. But yeah, that would be the only regulation really that we'd have. You just use the official logo.
Yeah. And if you needed to, we can get you the colors, the PMS numbers that they look for, and the sizing, and what can it be around. We have a whole rules on that, so I can easily send that over to you if you're looking for it, Mario.
Troy, what do you suppose Troy's asking there?
A water balancing class. I'm not sure, Troy. Could you be a little bit more specific? What do you mean by a water balancing class? And do we have a small banner I could hang in my classroom? We could probably get Bill a banner for the classroom. We got Dave's tablecloth in the back. We could send you that one.
So Brian, are you on Instagram at all? So hook me up on Instagram, Takeo Training, and just PM me there, and I will send out some stickers to you.
And if not, oh, awesome. So he is. Okay, good. Very good. Excellent. Excellent. Whew. I love the hardcore guys that stay on up to it's 9:45 now. It's 2 hours and 45 minutes. I love the hardcore guys. We say a 50, 80 y'all that are out there, plus the three of us. And who's the other staff guy? Tim Ward.
Ward, he's on.
Ward, are you napping? Are you with us here, man? Tim Ward is still hanging in there. At least he's logged in. We don't know if he's with us or not, but he's logged in, man. So good for you, Tim. Good for you.
I think he forgot. He might have forgot to log out.
He might have forgotten to log out. There you go. There's a very possibility there. So Brian's painting his son's room and listening to us while he's at it. All right, Brian, love it. I love it. I love it. Okay. How do I calculate pressure drop on a radiant manifold? Okay. How do we calculate? Are you talking about the manifold itself or the tubing connected to the manifold? That'd be a key point of differentiation there, Steve. The manifold itself.
Manufacturer will give you. Yeah.
Manufacturer will have that. Yeah.
V for each loop. Yeah.
Yeah. Because I remember when we did the back with Wurzbo, we never really the software, I guess, had it kind of built in.
Yep.
Whatever pressure drop there was through the manifold, but it wasn't a lot. You know, there was so much fudge built in and everything else that you did. The pressure drop through the manifold itself was very minimal. You know, so it was like, yeah, it's there. It's just there for distribution. And it's not that, it's only this long, and you got your valves there. And then you get the balancing valves themselves, which really the only purpose those things serve was to make the water think all of the loops were the same length, you know? So anything that you were likely to encounter there was fairly minimal. And your worst case head loss loop was always wide open anyway, so.
Yeah, this one of the things about manifolds is that you can actually drive yourself crazy, you know, if you're sitting to try to do the math across a manifold and fine tune it. You'll go nuts. You'll go you want to fine tune a manifold? Put an actuator on it and put a thermostat in the room, and that's your fine tuning to it. So, but the pressure drop in them, very, very minimal in a lot of the manifolds. Remember, most of our radiant, if you've got half-inch PEX connected to it, max flow is going to be, you know, residentially, 0.5 gallon a minute. Very low flow. The pressure drop, you could handle more through that loop on a manifold. You know, if you wanted to hook up 3/4 inch PEX, you can. But if you're using it for radiant floors and 3/8 and 1/2 inch and even the 5/16 style systems once in a while, pressure drop is very minimal through the manifold itself. It's more through the pipe, the length of pipe that you have connected to it, and then if you have a mix valve on there. But if you're trying to calculate the pressure drop and add it to the pressure drop of the pipe itself and make sure you got the right circulator on there and all that other jazz, it's going to be small. It's going to be pretty small. Yep.
Here's another one of these interesting questions. What are your thoughts on air-to-water heat pumps? Very, very favorable. Let's just leave it at that. Extraordinarily favorable to the point of we are avid fans of air-to-water heat pumps. We love them very, very much.
It's not a secret, JB. I mean, people have seen it.
Yeah, but it's more fun doing it this way.
Yeah.
Yeah,
Intrigued.
yeah, you will see something from in that space fairly soon.
Well, here's one thing with the whole idea or concept of electrification.
Hmm.
What keeps the hydronic industry in the loop?
Air to water heat pumps. That's
There
right.
you go.
And I know,
Low temperature heating. Yeah.
I know the three of us are very, very positive when it comes to low temp heating. You know, I love low temp heating. You know, you can do is get it as low as you can because that's just gonna make everything do what it's supposed to do, and you just feel a lot more comfortable in the house too. But you know, just to think about it for a second, when we go to a heat pump, that yes, it's going to have a limitation of its temperature that you can get out of it, but think about transfer, heat transfer for a second. The biggest thing that we have, two ways to heat houses today, right? Air and water. 3/4 inch pipe. 3/4 inch pipe will carry the same amount of BTUs as an 8 by 14 inch ductwork.
Hmm.
How hard is it to snake 3/4 inch pipe around a house? PEX or copper?
Yep.
Not that hard, right? 8 by 14 inch ductwork. Go snake that around.
Yeah. It's
Right?
and without cutting yourself.
Yeah, yeah. So yes, you know, if we're going to do it hydronically, you know, air to water heat pumps is definitely a way to go.
Yeah.
As we start talking about electrification, and also just, hey, let's start getting the efficiencies even higher compared to our high efficiency boilers nowadays, you know, so definitely.
Yeah, and what we mean by electrification is we're actually starting to see this in certain jurisdictions where you cannot get a new permit for natural gas, right? So different
Or
parts of the country,
propane or oil
or
or
propane or
yeah,
oil, they're
no
just saying no.
fossil fuel.
Yeah, any fossil fuel, whether it's infrastructure related or whatever, you cannot get a permit if you're building building new homes. Says, you know what? In this jurisdiction, you cannot get a permit for natural gas or oil or anything else. You just can't. So what are you going to do? How are you going to heat this place?
Yeah.
Good luck. That's where the heat pumps come in.
Yeah.
And air to water and low temperature. The lower the temperature of the water, obviously, the bigger the radiator you're going to need. All right. Obviously, I mean, and it's perfect for hydro air and it's perfect for radiant floor. Perfect for big radiators. You know, you start getting into bigger radiators, you're starting to get into things that you can provide the BTUs at low water temperatures. And then you've got a unit that thrives on making low water temperature, so it's all good.
So I had another question come in, but it didn't come into the main board. It came into me separately here. So from Rich Barron, what's up, brother? He had sent in, are the pole rings and the air separators and dirt bed made specifically for those products, or were they repurposed? They're made specifically. These were designed, the shape of those poles, I'll try to get this in there nice and close for you. But they were designed for that air separation. I can't get the focus to happen properly. There we go.
There they go.
All right. So yes, these were designed for this. They didn't come from anywhere else. It's a ring of stainless steel. Basically, what the engineers did was try to get as much surface area as possible on a piece of metal. All right, or shoved in the middle of an air separator. All right, they wanted to try to get it, but also have a lot of air. All right, meaning or space in between, so the water can easily pass through and not have much of a pressure drop to it. So and then have lots of surfaces on it. So, and by having all the different curves in there and the curls, you think of the water changing direction really fast as it goes from one side to the other, and the air and the dirt and the sediment and whatever's in there is not going to keep up. It's a collision into all those surfaces, and it in a dirt separator, it makes all the dirt fall out to the bottom, and an air separator is going to make all the little tiny air bubbles then separate and float to the top. By having something in the way, so that collision of that stuff is going to make it what's changes in there. So designed specifically just for these, and these are in the residential size from 3/4 inch to 2 inch, but then we go to bigger rings. They're about this diameter, in the commercial up to 36-inch pipe diameters.
Cool. Oh, Bill asked about with the air to water heat pump. What are we talking about for water temperatures? And we're talking about 120 to 140 max generally, and 140 might be pushing it.
Yeah, exactly. 120 is what we like to see. If you can go lower, even better. But once you start going lower than the 120, then you don't have the air handlers that can handle it that low. But you can go then radiant floors and/or panel rads in that instance if you wanted to go to, or even some low temp baseboard, some high efficiency or high output baseboard. A lot of fins. You know, there's one manufacturer in mind that I think of called Leading Edge.
Leading Edge,
Smith
Smith,
Environmental. Basically, when you look at that enclosure, the entire thing is a piece of aluminum on the inside instead of just the, you know, like a regular piece of fin tube baseboard where it's just the bottom third of it has aluminum in it. It's the entire enclosure has aluminum in there. So this way you get, you know, more surface area for heat transfer to occur, and you can operate that at the low temperatures very efficiently and effectively.
There you go. Bill says he runs 130 in Nebraska and it works well. Sure. It all depends on it. It's all up to the design of the heat emitter. You know, you can heat almost anything with 120-degree water if your heat emitters are big enough. Yeah. Here's one from Kerry. He says, does the heat pump work in colder climates, or since it's indoors, it works at a much warmer temperature? He says they'll work. The one we're looking at works to about 5 below, right?
Correct. Yep.
Yeah, and if you get temperatures below that, well, then there's backup, whether it's electric resistance or whatever, that would only run under those conditions. So yeah, you do have that practical level of limitation. You know, what's the coldest temperature that it really gets? Not what you think it gets. What does it really get? You know.
And then the percentage it gets to there too. So like if we were to add electric resistance in there, it doesn't need to handle the entire load. It just has to handle the difference.
Right.
You know, so it's very, very small that we would need to do that and make your meter start spinning even more.
Right. Right.
So
how does one check if an air separator is working properly?
Noise.
Yeah. If you got noise in your system, heat
babbling
transfer.
brook sounds.
Yeah.
Babbling brook sounds. Yeah.
Yeah.
Yep. Heat transfer can actually go down if you have a lot of air in the system. You're not getting as much heat transfer, so maybe the house may feel cooler, but will be probably oversized. What's that, Rick?
I said you'll hear it though.
Yeah.
If you got enough air in there that's messing up your heat transfer, you're going to hear it. So.
Yep. If you had a wish list, what product would you bring under the Takeo umbrella? Forged irons. Or milled putters. A nice milled putter. I'd like that.
We got to convert over a corner of the factory.
Yeah, I think we could. Well, we got the CNC milling machines. We could do it. We could definitely do it. Boy, you know, that's a loaded question, Richard, because you know there are things that would be cool to sell, but there were also things that if other people are selling them and do a better job, what credibility would we have? You know, like when Dave and I and Rick, we all three of us came over, people say, "Oh, great, is Takeo going to start selling PEX now?" Well, we could, but why?
Yeah.
what A, the world doesn't need another PEX manufacturer, and B, why would someone buy ours when there's already well-established companies that do it and do it very well. You know, so you gotta look at that. You know, line extension for the sake of line extension is never a good idea. You know, anything that we add would have to be done for a purpose. Yeah. You know, that said, there would be some cool things to add to the list, but you know,
think about the boiler manufacturers that have tried to add to their line just for the sake of doing it, and they realized that probably wasn't a good idea, and well,
Slantfin and Burnham both decided to get into the radiant business.
Yeah.
And Weil.
They're not the only ones.
And Weil, yes, that's right. Weil did too. Yeah, they all decided to get in the radiant business, and that just didn't work out because why?
Yeah.
The big question. There's already companies that do it better, that have been doing it longer, and have the street credibility. You know, at that point it becomes a price game, and as we all know from our radiant days, there's a lot. You can't sell radiant just on price because there's so much more support and whatever that goes into that. So you have to, it can't just be, you know, oh, sell you cheap pipe and we're done. You know, it doesn't work that way.
What we are focusing on as a company too is because we are international. You know, we are global as a company, and we have different companies. So we have us here in North America. We have Teco Italia. We have Teco Nova, also over in Switzerland, right? So we've got a lot of different things, you know, in each one of these companies when they were standalone companies. Now that we're all together as the Teco umbrella, for example, switching relays. All right. We don't sell those over in Europe whatsoever.
Right.
But
Because they don't use them over in Europe.
yeah, but they want to. Now they're starting to understand. I've heard this conversation before where, hey, what's the most efficient circ? John?
One that's off, baby.
The one that's off. Let's put a thermostat on a wall instead of making it run all the time. You know, so they're starting to hear that, you know, and to see our zone controllers go that way for a change instead of all the European stuff showing up on our stores,
Right.
seeing American stuff heading overseas, too. Not that there's anything wrong with one side or the other, right? It's just we do things differently, and it's not like one's better than the other. It's just, I think that's what we're also focusing on. We're taking a look at what Teco Nova has, and do we want to apply that to ours, rather than say, you know, why would we buy another company or buy another product and resell it or remanufacture it ourselves? Yeah.
The funniest thing I always about our European systems is we had this conversation, I don't know how many times, because people say, oh, the Europeans, they're so far ahead of us in technology and understanding, and there's so much, their systems are so much better than ours in residential hydronics. You know, one guy said to me, I'm embarrassed to be an American. I said, well, I'm embarrassed you're an American too with that attitude. I mean, come on. And it's not that anything's better or worse, man. It's just different. You know, it's just different. We have different levels. We have different expectations. We have different types of housing. We have different types of systems. They're different, and there's nothing wrong with different. Okay, I don't think one's necessarily better than the other. It always struck me as odd as people were talking about, well, they're so much more efficient over there. They're so much more efficient over there, yet they'll run the pump 24/7 for how many, 6,000 hours, which is basically, let's turn the pump on in September and shut it off in May. What's efficient about that? You know, why would you run a pump for that long? Well, it's continuous circulation. It's good. No, it's just, you're running a pump when you don't have to. You know, here we do something kooky and crazy. You know, when the thermostat's happy, we shut stuff off. I know, crazy, right? Nuts. Who would do such a thing? Well, I'm sorry, I'm ranting. But anyway, that said, we'll see what happens over there. There's a lot to learn about how, and not saying that the Europeans are wrong, that it's wrong how they do it. It works over there. That's how they do it. And why they do it that way is very interesting too. When you ask questions, you learn stuff. Maybe I should share that story. Let me ask you guys, there's 50 of you out there. Would you like me to share the evolution of American heating systems versus European heating systems? Carrie says, yep. Okay, Carrie, you are the spokesman for tonight. I can do it in 5 minutes. Yeah, I can do it in 5 minutes right now. Several years ago in England, they had something called the boiler scrappage scheme. And it was, it was an incentive program. It was a government and utility funded incentive that gave homeowners a rebate for them to upgrade their boiler to a more efficient model, a wall hung, high efficiency condensing technology. And to promote this program, they ran a contest. In England, they wanted to find the oldest operating boiler in England. Okay, the oldest operating residential boiler in all of England. Now, understand this about England. Shakespeare wrote his sonnets and As You Like It and Romeo and Juliet long before anything over here was even settled, okay, by the Europeans. There were, We had the indigenous population with societies, but Columbus hadn't come over yet and spoiled everything. So that's how old that island is, that civilization is. For those of you who are still listening and care, what year do you think they finally found it? What year do you think the oldest operating residential boiler in all of England was installed? They found it and they verified it. What year do you think it was installed? 1865 we have. 1850 we have. 1890 we have. What else? What else do you think, guys? 1888. 1780. Oh boy, you guys, this is pretty good. This is pretty good. When did it come out? There's Brian Foley. There you go. When did 1792? 1968. 1968. That was the year the White Album came out by the Beatles. Okay, 1968. That floored me, man. I didn't. Wait a minute. This is old. Right. It comes down to this. Throughout Europe, residential hydronics is not that old. All right, it's not. It's really not an old idea. Up until World War II, really, where did most people live in Europe? They either lived out on farms and the homes were heated with, with the hearth, with the fireplace, okay, or they lived in cities, in flats that were heated by coal. Okay, that was how these things were heated. Okay, after the war, there was no residential building boom like there was here in the U.S. They had other priorities. There wasn't really a residential building boom until the early 70s throughout much of Europe. So they really weren't building new homes there. They had scads and scads of old homes. Now they were trying to retrofit a lot of these old homes to central heating systems because they noticed they had a pollution problem. All those decades of burning coal weren't doing any of the polluting the air. It wasn't doing the air any favors. So they started to incentivize that. But for many years, if anybody here ever tried to retrofit a really old house with a hydronic heating system using copper and fire, okay, it wasn't easy. It was very, very difficult. Unfortunately, or fortunately, in 1968, we had a development that made it a heck of a lot easier, and that development was PEX. All right, that's when we started getting PEX, and that made it a heck of a lot easier to retrofit these older existing homes with a central hydronic system. Now, what was the easiest thing for them to do? Well, if you've ever retrofitted a house, you know what the easiest thing to do is to take two small pipes, right? Two small pipes. We're talking 14 millimeter, and that's to run from the mechanical room, a home run supply and return to this room, a home run supply and return to this room, a home run supply and return to that room, and a home run supply and return to that room, and then hook up a radiator. All right. Nobody's running thermostats. Nobody's running thermostat wires. They don't have that kind of time. What do? They develop thermostatic radiator valves to control the comfort level at each radiator. So everything comes back to a central manifold in the mechanical room. The boiler's going to do what the boiler's going to do. All right. And then they just have a pump to make the water go round and round. Since there's no thermostats to turn the pump on and off, the easiest thing to do is put it on a switch, put the pump on a switch. Let's turn it on in September and turn it off in May. That's the evolution of the European residential hydronic heating system. Now there have been developments of that. You've got more efficient boilers that work off of outdoor reset. You've got better piping materials, etc. Panel radiators that are really nice, but they're still operated by a thermostatic radiator valve and a pump that still runs continuously. It might be on an aquastat now, so when it gets below a certain temperature outside, it'll turn on. All right, so it's not on a switch anymore, but that's your basic European style heating system, and it works beautifully. But the reason they do it that way isn't because it was inherently superior or inherently better, or they did a lot of analysis to figure that out. It's because it was the most convenient way they had to retrofit existing homes, and then they just converted that to
that's how they did systems, and they just took that, put it in new homes. Now over here, we were building houses, we were building big houses, and we were putting in systems as we were building the house. So we were able to put in larger pipes, series loops of baseboard, became very easy to install while the house is being built. Cast iron radiators, you know, the Venturi systems, all those things were very convenient and easy to do. Our types of the circulators that have, you know, flat curve circulators, high flow, low head, flat curve circulators, that pump curve is called the American style curve because it was designed for American style systems. It was purposely made that way to satisfy the needs of the systems that are being installed. Necessity was the mother of invention. European style curves tend to be steeper, lower flow, higher head, steeper curves because that's what they needed over there with those 14 millimeter supply and returns to each radiator. Lower flow because they designed to a 40-degree delta T instead of a 20 here, but man, they had higher head because it was a small pipe. So that's kind of how that all worked, man, and that's how things developed the way they did. Better, worse, no difference in my book. It's just that they are different, and I don't think one is inherently better than the other. So there we go. That's my story, and I'm sticking to it. And what did Dr. Renee here say? Published
Same thing. Yeah, I guess he's founding the 1968 project. Yep.
Yep. Yeah, 42-year-old appliance in Villa-Rica. Yeah, Colin Sadler. That's right. I looked that up too. Yeah. Yeah, it was. I remember looking up what he said about it. It was still going strong. He had it. It was old when they thought it was old when they moved into the house. But they still kept going. And here, you know, it was 42 years old. If there was a 42-year-old boiler if you bought a house in the U.S. with a 42-year-old boiler, you're thinking that's still good. That thing's got another 20 years left to it if we take care of it, man. You know.
Yeah, put another burner in it, call it a day.
Yeah, we're good. The Crane Cavalier. Yes, that's right. I love it. So yeah, really cool, a very cool story. And again, it's just, you learn history teaches us an awful lot if we kind of look back on how things evolved and how they became the way they are. You know, I mean, it's just, to me, it's very fascinating. It's very, very fascinating. So, you know, perspective is all. I remember I told the story last week about my dad when, you know, I was complaining about having to draw out pipe on every room for radiant floor heating. We said they had to do the same thing back when somebody tried to sell them fin tube baseboard back in the late 40s, early 50s. They didn't think it was going to work. No, perspective is all. That's all we have. And it's after 10 o'clock, guys. I think we set another record.
Yeah, man.
Brian's saying that he thinks the audio dropped out. I think.
No, man, I just
drop out. Yeah.
Brian said just yakety.
I tune them out all the time, Brian, myself.
Yeah, you go. Brian, my only marketable skill is the ability to talk for 3 days straight without getting bored or tired. Okay, if I couldn't do this, I would be a burden on society. Okay, so just be thankful. All righty. Hey.
Oh yeah.
Probably a good time for us to close the book on tonight.
Sayonara.
It may be. You got to save some fun for the next couple of weeks still.
There we go. All righty, guys. Hey, thank you all for being with us. Absolutely love having you tonight and love sharing this time with you. So thank you so very much for being with us. We do appreciate it.
Thank you.
And we will all see you next week.
Next
Wednesday. Same bat time.
Same bat channel. And same bat bleep crazy guys. So
that's right.
Yeah.
We'll talk to y'all next week, guys. Take care.
Good night, all.